Hey, scientists may have just found a new planet that looks a lot like Earth, with a big icy catch. This world is about 150 light-years away, rocky, and circles a sun-like star on a schedule pretty close to ours. At first sight, it sounds promising, right? Well, slow down. There's a catch here. It might be insanely cold as Mars in the deep freeze. You see, HD 137010b, that's a mouthful, doesn't seem to be a gas ball, so we would probably be able to stand on its surface. It's a little bigger than Earth and goes around a star that's pretty similar to our Sun. This star is about 146 light-years away from our planet, which, in space terms, is close enough for scientists to study it instead of just, squinting at it. But what made people excited is the fact that this planet takes about 1 Earth year to go around its star. Now that's a big deal, because most exoplanets dash around their stars in days or weeks. Even better, this newly discovered one might sit right on the outer edge of the habitable zone, also called the Goldilocks zone. This region is not too hot and not too cold, which means that liquid water might exist on the planet if it has the right atmosphere. A big if, but still cool. Another thing that makes this planet extra special is how we see it. From Earth, it actually passes in front of its star. Imagine a tiny bug crawling across a flashlight beam. You got it. That makes it way easier for scientists to study things like its size, orbit, and maybe even what its atmosphere is made of. And if all of this checks out, it could be one of the best Earth-like planet candidates we've ever found. And now, the bad news. This planet does not get much sunlight. HD 137010b gets less than 1/3 of the heat and light Earth gets from the Sun. Even though its star is similar to our Sun, it's basically the Sun's quieter, dimmer cousin. Same type, lower wattage. What does that mean for the planet? It could be insanely cold. Scientists think the surface temperature might max out at around minus 90 degrees Fahrenheit. And that's not a grab-a-jacket cold, that's your face freezes right away cold. For comparison, Mars has an average temperature of around minus 85 degrees Fahrenheit. So this planet could actually be colder than Mars, a frozen desert, not to be confused with a frozen dessert, that looks like it gave up on life a long time ago. Another plot twist: this planet isn't officially a planet yet. At the moment, it's still labeled a candidate. Scientists usually confirm planets by watching them pass in front of their star over and over again. Every time that happens, the star dims just a little bit. But with this new space body, we've only seen one transit, a single 10-hour-long mini-eclipse, spotted during Kepler's second mission, called K2. Even with that one pass, astronomers could still learn a lot. They measured how long the planet's shadow took to cross the star, about 10 hours. For comparison, Earth takes about 13 hours to cross the Sun. Then, they plugged that into orbital models and estimated that the planet probably takes about a year to go around its star. That's impressive, but it's still not enough. Astronomers need to see that dip in starlight repeat on schedule to be sure it's really a planet and not some weird stellar wanderer. Unfortunately, this planet orbits far out, and those transits are rare. You don't get one every few days or weeks. You might have to wait a year or more for the next one. That's one of the big reasons Earth-like planets are so hard to find in the first place. So now, scientists are just hoping that other space telescopes can help out. NASA's TESS might catch another transit, or Europe's Cheops telescope could help pin it down. If neither of those catches it, we might have to wait for the next generation of space telescopes to get better data. Because even though this planet sounds like an ice cube in space, it's not totally doomed. If it has a thick atmosphere, especially if it's rich in carbon dioxide, it could trap heat really well, like a planet-sized winter coat. In that case, the planet might actually have a mild climate, or even liquid water on its surface. Well, based on computer models, scientists say there's about a 40% chance this distant world sits in the safe, conservative, habitable zone. A chance that is located in a more relaxed, optimistic habitable zone reaches 51%. But there's also a 50-50 chance that the planet is actually outside the habitable zone altogether. In other words, this planet is basically a cosmic coin toss. It could be a frozen wasteland, worse than Mars, a chilly, barely survivable world, or a watery planet hiding under a thick atmosphere. HD 137010b isn't the only place that has the potential to host human civilization in the future. In recent years, astronomers have been spotting new super-Earth planets orbiting remote stars. Now, checking our space vocabulary, super-Earth means a planet beyond the solar system with a mass higher than that of Earth, but below those of the ice giants of the solar system, Uranus and Neptune. One of those planets is Gliese 667cc. It's just 22 light-years from Earth. But even though it seems pretty close, it's still around 129 trillion miles away from us. That's around 1.4 million times the average distance from the Earth to the Sun, so very, very far. The planet itself is around 3.8 times as massive as Earth, and completes one orbit around its host star within 28 days. In other words, a year on that Earth-like planet is 13 times shorter than a year on our planet. Luckily, the star is a cool red dwarf, so the exoplanet most likely lies in its habitable zone. But there's still a chance that this world might be regularly baked by the flares from its parent star. Then there's Kepler 22b. This world is way farther away than the previous world, more like 600 light-years away from our planet. It's larger than Earth and is about 2.5 times our planet's size. Sadly, we still don't know whether this planet is rocky, liquid, or gaseous. The orbit of Kepler 22b is pretty similar to Earth's. It takes the planet 290 days to orbit its G-class star, which is kinda similar to our Sun. But this star is smaller and colder than ours. Now, don't confuse this world with Kepler 69c. It lies a whopping 2,700 light-years away from us and is almost 70% larger than Earth. Researchers know nothing about its composition, but they found out that the planet needs 242 days to complete one orbit. This makes its position in its system similar to that of Venus in our solar system. At the same time, this world might be more hospitable than Venus since its host star is a bit less luminous, 80% of our Sun. As for our Venus, it's an extremely hostile place. You don't want to go there. A runaway greenhouse effect caused by an atmosphere that's about 96% carbon dioxide traps the heat. That pushes surface temperatures up to around 878 degrees Fahrenheit, which is hot enough to melt lead. On top of that, the air pressure is about 90 times stronger than that of Earth, and the whole planet is covered in thick clouds of corrosive sulfuric acid. Oh boy. Compared to our neighbor, TOI 733b seems like a pretty friendly world. This planet was found in 2023. It's floating 245 light-years away from Earth. The coolest thing about this planet is that it might have a massive ocean. According to scientists, this planet is likely to be completely covered with water. Does it mean there could be life on this super-Earth? Well, time will show. And who knows? Maybe soon we'll find even more planets that could become a new home for people looking to explore the universe. As for HD 137010b, the fact that it checks so many Earth-style boxes makes it a really interesting find. It's not a backup Earth yet, but it makes scientists stop and say, okay, this one's worth a closer look, or something similar. Well, I hate to break it to you, but I'm told that our Earth might not be so special after all. Scientists say it could just be the last planet in our solar system that hasn't moved on yet. Yep, the worrying part is that it looks like planets don't stay Earth-like forever. They pass through it. Atmosphere, liquid water, internal heat, magnetic shields – all that lines up for a while, and then, slowly, it unravels. Now, for a long time, scientists treated Earth-like planets as cosmic unicorns, 1 in 100 star kind of rare. But when they ran updated models with better physics and geology, researchers realized that if the conditions line up, Earth-like planets with liquid water could exist around almost every star. Not 1 in 100, potentially 1 per star. That's 100 times more common than they thought. Our Milky Way alone has at least 100 billion stars. Hey, suddenly the universe doesn't feel empty at all, and planets don't even need oceans splashing on the surface to count. Many worlds that look frozen on the outside could be hiding liquid water deep below their crusts. quietly warm and stable. It's already happening in our own backyard. Moons like Europa and Ganymede around Jupiter and Enceladus around Saturn look like icy balls from space, but underneath their cracked shells there are global saltwater oceans. Even dwarf planets like Pluto and Ceres show signs of buried water. The secret sauce is heat. Radioactive elements inside a planet slowly release energy, like a tiny heater that never shuts off. Plus, gravity from nearby giant planets stretches and squeezes these worlds and creates friction heat. So, it seems pretty easy for Earth-like planets to form. And if you look at modern planet formation models, you'll see rocky planets like ours pop up all the time. It's possible that the early solar system didn't just make one Earth. It made several attempts. Mercury, Venus, Earth, and Mars all formed from the same neighborhood, same materials, same chaos. Exploding stars nearby, called supernovae, sprayed heavy elements like iron and nickel into the cloud that became our planets. That gave them solid cores, internal heat, and the potential for magnetic fields. That's the starter kit for an Earth-like world. So instead of Earth being a miracle, it starts to look like the survivor of a group project where everyone else dropped out. Now, Mars is the first planet in this dropout group that has been actively giving away clues that it wasn't always the dry, rusty place we see today. Scientists have spotted river deltas, minerals that only form in water, and landscapes that look carved rather than blasted. All signs point to the same thing: Mars used to be wet. The big question was never if there was water, but what kind of world it created. Was Mars frozen with bursts of melting ice, or was it warm enough to hold long-lasting oceans? New evidence tips the scale towards something huge. Around 3 billion years ago, Mars likely had a massive ocean covering most of its northern hemisphere. It was not a patchwork of lakes, but one connected body of water. That idea comes from studying the biggest canyon system in the solar system. It stretches about 2,500 miles long and up to 120 miles wide, dwarfing Earth's Grand Canyon by comparison. There is an area inside the canyon where signs point to a deep ancient lake. Scientists found special layered deposits along the canyon walls that show rivers once flowed into the canyon. Even stranger, all these deposits sit at almost exactly the same height. That tells us the water level stayed stable for a long time, and depths reached nearly 3,300 feet in some places. The canyon floor sits higher than Mars's northern lowlands. If water filled the canyon that deeply, it had to spill outward, flooding the entire northern half of the planet. In other words, Mars wasn't just wet, it was blue. This discovery comes with a warning. Mars shows how precious water really is and how easily a planet can lose it. It looks like Mars didn't fail because it was weird or flawed. Studies now show its core stayed hot and solid for a long time, very Earth-like in structure. The difference is in size. Mars is smaller, so it cooled faster. Once the core slowed, the magnetic field weakened. Once the field weakened, the atmosphere started leaking into space. It's like trying to hold water in a bucket full of tiny holes. Eventually, gravity loses the fight. Alright, and what about Venus and its potential for life? It has always looked like Earth's evil twin: poisonous air, crushing pressure, surface hot enough to melt lead. But NASA's Magellan mission back in the early 1990s collected some data that tells a completely different story, one where Venus might still be alive on the inside. Magellan arrived at Venus and did something no spacecraft had done before. It mapped the entire planet's surface and gravity field in detail. At the time, scientists mostly used the images to catalog craters and strange landforms. But now, with better models and computing power, researchers are rereading that data and realizing Venus may be far more geologically active than anyone assumed. The biggest clue comes from massive features called coronae. These are large, almost circular formations that can stretch dozens to hundreds of miles across. It's like a giant blister in the planet's crust. Venus doesn't have moving tectonic plates like Earth, but that doesn't mean nothing moves. Hot, buoyant material from deep inside the planet, the mantle, can push upward, warping and cracking the surface from below. When they combined Magellan's gravity data with its topography maps, scientists managed to peek beneath Venus's crust. They noticed hidden mantle plumes, rising columns of hot rock that don't always show up in surface images alone. Around some coronae, researchers even found signs of subduction, where one section of crust sinks beneath another. Plus, something called lithospheric dripping, where dense surface material slowly sinks back into the mantle like cooling wax. Now all this sounds cool, but it starts feeling way more personal when you find out Earth may have looked like this once. Coronae don't exist on modern Earth, but they might have formed billions of years ago, before plate tectonics fully took over. Studying Venus today could be like looking at a snapshot of Earth's deep past. And this is just the warm-up. NASA's Veritas mission will return to Venus with modern radar, build 3D global maps, analyze surface chemistry, and measure the planet's gravity field in far greater detail, up to 4 times sharper than Magellan. If Venus is still shifting, dripping, and churning inside, Veritas will catch it in the act. Now, Venus isn't the only planet getting a second look thanks to dusty old data files. Back in 1986, Voyager 2 flew past Uranus and sent back a snapshot that confused everyone. Uranus looked like a cold, tilted, icy giant wrapped in one of the strangest magnetic bubbles ever seen. Its magnetosphere, the invisible magnetic shield around the planet, made no sense. It was tilted by about 59 degrees, shoved off-center inside the planet, and paired with a planet already lying on its side at a 98-degree tilt. Even weirder, Voyager 2 found that Uranus's magnetosphere was almost empty. Very little plasma hung around inside it. Instead, scientists saw dense belts of high-energy electrons, packed way tighter than expected. For decades, researchers assumed this was just how Uranus worked, a permanently broken magnetic system. But now, they reanalyzed Voyager 2's data with modern tools and decades of new knowledge about space weather. And it looks like Voyager 2 didn't catch Uranus in its normal state at all. It caught it when a solar storm was passing Uranus. So Uranus might not be permanently weird. And since our entire understanding of Uranus is based on a single flyby during a cosmic storm, it could be hiding plenty of secrets. Put all this together, and the solar system starts to look less like a tidy family and more like a graveyard of transformed former Earths. And when scientists say Earth isn't a planet type, but a phase, they're not just being dramatic. Earth just happens to be the last one in the solar system still holding the line.
In 2024, Earth was joined by a mini-moon that orbited around our planet for 2 months. It hung around, made a few laps, and then, like every polite guest, it left. It went back to resume its trip around the Sun. However, astronomers now say another rock has been tagging along with Earth not for weeks, but for 6 decades. It's rare and strange, now being classified as a quasi-moon. But what exactly does that mean? Is it like a backup satellite? Unlike our cool and mysterious moon that illuminates our nights and affects werewolves, a quasi-moon doesn't circle Earth. Instead, it orbits the Sun, but it does so almost in perfect sync with us, like a runner doing a marathon with you that keeps a similar pace. Space only seems calm. It's actually pretty chaotic. The Sun, the Moon, Earth, and even other planets are constantly tugging on each other and smaller objects like these rocks. Most asteroids can't hold this delicate balance for long. They either get nudged into a new orbit, pulled closer to Earth, or flung out into the vast reaches of space. That's why we're lucky to spot more than 1 or 2 at a time. Most just can't keep the balance. They belong to a bigger family called co-orbitals. In fact, astronomers group them into a few types based on how they move relative to Earth. But unlike the real moon, that's been our companion since the very beginning, these visitors don't stick around forever. Some hang with us for a few decades, others for centuries, before drifting away because the gravity of some other space object. Kinda like a dog running to your neighbor after smelling bacon. One other thing about quasi-moons is their size. Most are tiny, building-sized or even smaller. They're also so dim that they can hide in plain sight among stars. Still, they're important. By studying them, astronomers learn how small near-Earth objects move and how long they can stay caught in Earth's gravity. Quasi-moons are closer than other asteroids on the same path, and it would be easier to reach them. One day, they might be used as stepping stones in space exploration. Earth has had a few of these tag-alongs before. One of the most famous is 2016 HO3, nicknamed Earth's Constant Companion. It's only about 300 feet wide, but it's been keeping pace with us for nearly a century. Researchers say it might keep up for centuries more. But what about the most recently discovered one? The researchers named it 2025 PN7. Like we said, it's already been with us for 60 years and will likely stay for around 68 more. For a long time, it remained undiscovered because of its tiny size, only about 62 feet across, which is about the length of a bowling lane. This also answers the question of whether you could see it yourself if you knew where to look. Its backstory is a bit of a mystery. Astronomers haven't figured out its composition yet. Right now, all we know for sure is its trajectory. Some quasi-moons are just near-Earth asteroids that fell into a perfect orbit. Others seem like they could be chunks of the moon itself. For instance, there's another quasi-moon named Kamo'olawea that reflects light in almost the same way as the lunar rocks we brought back during the Apollo missions. Because of that, some researchers think it might actually be leftover from a huge impact that happened long ago. There's also 2024 PT5, a temporary mini-moon from the end of last year. Tests showed that its surface looks like lunar basalt, suggesting it probably came from the moon. So how do these quasi-moons pull off their cosmic balancing act? That's because it's just an orbital illusion. Remember, PN7, like other quasi-moons, isn't actually circling our planet. To us, it looks like the rock is scribbling lazy loops around Earth's path, like doodles in space. Yet it never lags too much or gets too far. Astronomers call this a one-to-one resonance. In plain English, it makes a lap around the sun every time Earth does. Another fun question. If these fake moons are so close to Earth, why don't we just pull them in with our gravity? Especially since they're tiny and seem so near. That's because even though they belong to a group called near-Earth objects, quasi-moons are not that close. Our moon is hanging out about 239,000 miles away. These companions, though, are flying around the sun millions of miles out, way beyond Earth's gravitational pull. That pull exists within an area called the Hill sphere, which is where Earth's gravity is stronger than the sun's. Think of Earth's gravity as a bubble with a radius of about 1,000,000 miles. Anything inside can get caught, like the real moon. Step outside and the sun takes over. This is exactly what happened to PT5, which was our legit satellite for 2 months in 2024. It dipped inside the Hill sphere and Earth's gravity took over. Once it happened, this object became known as a mini-moon. But because it was small and moving fast, it eventually slipped back out of that bubble, and the sun's gravity pulled it away again. One other type of co-orbiter, aside from quasi-moons and mini-moons, is the so-called horseshoe orbiters. These space rocks don't stray far, but from Earth's point of view, they seem to swing ahead of us, slow down, then drift back behind, and repeat. It's like an undercover cop tailing you in traffic, but constantly switching lanes and doubling back so you don't notice the pattern. If you trace their motion from Earth, over time, it forms a giant horseshoe shape, hence the name. And these are just the main co-orbiters. There are actually more. Way ahead of us and way behind us in space, there are a few quirky rocks called Trojans. They're not just following right next to Earth like quasi-moons do. Instead, they found 2 special hiding spots. One 60 degrees in front of us and one 60 degrees behind. Imagine riding your bike and having a friend way ahead of you and another one way behind, both keeping the same speed. That's what Trojans do. Those spots are called Lagrange points, cozy hangout regions where the gravitational pulls from Earth and the Sun balance out perfectly. When they find themselves in one of those areas, they could be staying there for millions of years without drifting away. Jupiter, for example, has tons of these freeloaders. Earth has only a few. Then there are tadpole orbiters. Instead of sitting perfectly still in a Lagrange point, they wobble around it in lazy bean-shaped loops. And if that's not confusing and overwhelming enough, there are also jumping Trojans, the indecisive ones. These guys can't pick a side. They'll spend a few thousand years staying in the front hammock, then slowly drift to one behind us and back again. Rare, weird, and kind of awesome. So even though Earth only has one big moon in the sky, we've actually got a whole gang of intrusive space tag-alongs. Some loop, some trail, some hide in the corners. Now let's recap the superpowers of our moon. It can affect tides, slow down Earth's rotation, and even help stabilize our planet's tilt. Without the moon, our days would be shorter, our nights darker, and the seasons way more chaotic. The moon also acts like a giant shield, sweeping up or deflecting some space rocks that might otherwise smack into Earth. And let's not forget its cultural influence. It's been inspiring myths, calendars, love songs, and millions of melancholic walks in the middle of the night. Fake moons can't compete. However, they are important in their own way. Each new quasi-moon we find helps us understand how these little rocks survive in all that cosmic chaos. By learning about our environment, we also learn something about ourselves. They sharpen our detection skills and help us improve our models. So while they'll never shine in the night sky, they still play a quiet role in helping us understand our quirky cosmic neighborhood.
The only life that we are certain about so far in the entire universe is on planet Earth. Whether that life is intelligent is, let's say, arguable. But anyway, it's not surprising that we're tirelessly searching for life on other planets. So far, they've discovered more than 4,000 of them. But what's even cooler, NASA has compiled a new list of 24 planets that aren't just Earth-like, they're better. The conditions on them are so good that they're more comfortable than on our planet. So let's examine some of them. KOI 5715.01. Let's be coy, shall we? This wonderful planet is in the constellation Cygnus. And why is it so wonderful? Well, our sun is a yellow dwarf. And sorry, son, even though you're not bad at supporting life, there are some stars that can do it better. Nothing personal. The planet KOI 5715.01 orbits near an orange dwarf. Orange dwarfs are stars slightly smaller than our sun and have a little lower luminosity. Did you like the alliteration there? Anyway, don't worry, it doesn't mean we're going to live in complete darkness. In fact, if the planet is found closer to the Sun and it has a thicker atmosphere, it may even be lighter and more colorful than on Earth. Now, our Sun has a very short lifespan. Right now, it has 7 to 8 billion years left to live, a little longer than Earth's age. But orange dwarfs can live from 45 to 70 billion years. This is great not only because we'll be able to hang out on this planet longer, but also because the planets around these stars have more time to form life. Now, ideally, we would need to find a planet next to an orange dwarf that is about 7 billion years old. It's very likely there will be at least some organisms there. KOI 5715.01 is about 5.5 billion years old. Yeah, it may not seem mature enough, but that's okay, neither do I. Our Earth is a billion years younger, and that didn't stop us. The planet is quite close to its star and is in a habitable zone. 1 year there lasts 190 days. Imagine going to elementary school and already getting a driver's license. It's almost 2 times larger than the Earth. The average temperature there is 52 degrees Fahrenheit, which is slightly less than ours, 57. But it mostly feels warmer there because strong gravity helps it hold on to heat in the atmosphere longer. It's a little too far away though, like 3,000 light-years from Earth, which is about 18 quadrillion miles. Yep, better bring a really big lunch with you. KOI 3010.01. This planet is found next to the star KOI 2010. This planet sounds like a very pleasant world. The average temperature on this planet is 67 degrees, so a little warmer than ours. But that's a good thing. Scientists believe that on a perfect planet, the temperature should be just about 10 degrees hotter than on Earth. The more heat there is on the planet, the more comfortable it is to live there. Also, the higher chances of developing life. The radius of this planet is nearly 1.5 times larger than Earth. There's some atmosphere, although we're not yet sure about its composition, but it's probably like the Earth's. Scientists think that we'll find an ocean there, and it can cover up to 60% of the surface, which is also cool. In a perfect world, water and land should be distributed more evenly than on our planet. A little more land means a little more territory and resources, right? But listen, this planet is actually very similar to the Earth. The semblance is so striking that scientists believe we have an 84% chance to find life there. Of course, not necessarily an intelligent life, but at least some animals. Wouldn't that be cool? Now, what do you think they could look like? Very Earth-like planet, but with stronger gravity. Well, if someone lives there, they're probably big but have a small height and strong little legs. Sounds adorable and scary. But we won't be able to find out the truth anytime soon. So far, for us, these planets are microscopic dots in space. We only have some dry, boring data about them and don't even know what they look like. We'll have to wait until we can find a way to get closer to these planets. Kepler 186f. This is also one of the best candidates for having life. This rather cute planet was nicknamed the Earth's cousin because it does have a strong resemblance. Anyway, these two planets are like sisters, not twins. Kepler 186f rotates near a red dwarf. Red dwarfs are stars even dimmer and smaller than orange dwarfs. Yeah, they'll also live for a very, very long time, but their luminosity is also quite low. However, Kepler 186f is closer to its star than we're to our Sun, so it shouldn't be too dark there. Well, at least not night-like dark. The sky on this planet is sure to be an unusual shade of red, like sunsets on Earth. What do you think? Would you like to live on a planet with an eternal sunset? The size of this planet is about the same as Earth. Not bad, not perfect. Why so? Because the coolest planets are those that are bigger than Earth and have stronger gravity. Now you'll probably say, but wouldn't it be harder to walk there and even harder to get out of bed on Monday? Of course. But on the other hand, this planet will pull the atmosphere better. The atmosphere will be thicker and denser. This means more protection from the scary space stuff, more oxygen, and more heat. Not to mention the fact that the bigger planets have more space to settle. Awesome, right? But of course, the Earth's size is also an excellent choice. Another cool fact is that the tilt of Kepler 186f is about the same as ours. It means that there should be stable seasons and a normal day-night cycle. Do you know how important the tilt of the planet is? Let's look at Mars. Mars is also, in fact, found in the habitable zone of our Sun, but its tilt is very unstable, and as a result, the entire ocean that could have been on it once now completely dried up. Today, it's just a red desert, and there's no life there. At least not as far as we know, but you see how important these tiny details are? This planet is also quite far away from us, 490 light-years. That's about 3 quadrillion miles. So yeah, we're just going to keep waiting for intergalactic travel. Kepler 62e and 62f. These planets were called the most Earth-like before we discovered Kepler 186f. They're very comparable to our home. Kepler 62e is about 1.5 times larger than Earth, and Kepler 62f is just slightly smaller than that. They're located in the constellation Lyra, which is about 1,200 light-years away from us. They both also orbit a red dwarf. 1 year on Kepler 62e lasts about 122 days, even less than on that first planet we talked about. Scientists believe that both 62e and 62f are sort of water worlds. warm places mostly, or even completely covered with water. If there is land there, it's probably just some islands. A world consisting entirely of islands. A fantasy dream for some, think Hawaii, and a nightmare for others, think Megalodon. But if you're a fan of ancient marine animals, just imagine how gigantic they could be there. Still, there are many things we don't know about this planet. Does it have a surface? What about its composition, density? One day, maybe we'll be able to answer these questions. And so, that's it for the super Earths. Of course, the original list is much longer, and you can go check it out on the internet. Now, the best thing about all this is that these are planets that are better than the Earth. But we also know thousands of other exoplanets that are just close enough to ours. And the odds are, a few of them have at least some form of life. But they're very, very far away, so we have no way to check it out right now. Perhaps, down the road, we'll find some cool creatures on many of them.
This is Neptune. The next stop is Pluto. Stand clear of the closing doors, please.
One day, with top-notch future technologies, one stop from Neptune to Pluto won't seem much further than Times Square from Bryant Park today. There are huge ice mountains on Pluto, valleys that go further than your eyes can see, 160-mile large craters, almost as big as the largest one on Earth, and no life. The reasons are obvious. The long distance between Pluto and the Sun guarantees freezing temperatures on that dwarf planet. It also ensures a trip of a few billion miles. Plus, it's smaller than the Moon, so it would get crowded very soon if people started dwelling there. Still, there's one reason which makes life there not that far-fetched. The Sun has a lifespan and cycles within it. Our solar system used to be nothing but a cloud of gas and dust. As a result of a gravitational collapse at the center of this cloud, the gas and dust started gathering in specific, denser places. These pulled more and more matter as time went on, and something called conservation momentum made the mass start rotating and heating up because of immense pressure. Later, there appeared a disk similar to what Saturn has, but it was made of entirely different substances. And right in the center, there was the ball that eventually became the Sun. A protostar is a young star that's still gathering its mass, and that's exactly what the Sun was before the temperatures and pressures inside of it lighted up its core. Millions of years later, it became the Sun we see every day. But it won't stay this way forever. It will heat up even more and eventually get bigger and denser, turning into a red giant. It may one day get big enough to swallow up Venus and Mercury. Chances are, it might swallow even planet Earth. Even if it doesn't devour our planet, the Sun might get close enough to touch us. Well, if this happened, life on Earth wouldn't be possible. But then, in just a few minutes, the Sun loses about 40% of its mass and shrinks about 10 times what it used to be. It's not as bright, and indeed, not as hot as it used to be. By this moment, Earth will have already been deserted. People might want to start traveling around space, or settle down on another planet where life is sustainable, like the exoplanet Kepler-62f, which, by the way, is even bigger than Earth. While all of this was happening, Pluto was changing. Before, every resource was frozen inside of the dwarf planet. Water, gases like methane, carbon monoxide, you name it. But as the Sun was reaching its peak luminosity, Pluto was slowly warming up and losing a lot of what it had to the vastness of space. At the same time, an atmosphere formed up. If the atmosphere gets thick enough, it would create favorable life conditions. Then, instead of spaceships, a tiny percentage of us would be able to set up colonies on the dwarf planet. The temperature is comfortable there, almost t-shirt weather. It even resembles Earth a tiny bit. Canyons filled with water, beautiful endless fields with trees, and lots of space to run around, and mineral water pockets on the ground, good enough to drink. Pluto's rotations are different than Earth's. An Earth day is 24 hours, and sometimes it still feels like it never ends. But on Pluto, a whole rotation around the Sun takes 153 hours, because it's pretty far away from the Sun. After several hours without sleep, we get tired, and our eyes get red. It means we'd have to take several naps throughout the day on Pluto. A year on Pluto equals 248 Earth years. Unless we come up with some sort of technology to get us to live that long, our entire lifespan would be less than half a year on the dwarf planet. So, houses on Pluto might need to be equipped with cryo chambers. Whenever you feel like dreaming for a long time, you jump in it and wake up 50 Pluto days later. On the dwarf planet, there are also seas and beaches, so it's just like a tiny Earth, far away from the actual Earth. The food on Pluto could be tastier. We might find a way to make the ingredients more savory and even try to grow them faster during the trip. You plant a carrot, and 2 days later, it's ready to be in your salad. There could also be new ingredients for our salads on Pluto. Maybe 2-meter-tall mushrooms we've never seen before. The animals we would take with us on the trip would get released into their new home forever. And with time, they would evolve and adapt to their new environments. The law of the jungle could change a bit too. Lions might not be kings anymore. Deer are. Their antlers are twice the size of what they used to be. But to be fair, so are the deer. Most of the animals that were already here used to live underwater. But with time, the amphibians started shifting to the surface, just like Earth at the beginning of life. Pluto could only be a temporary home though. Once the sun has finally reached its final phase, Pluto would get frozen and lifeless again. People instead would need to try to find a planet that stays in the Goldilocks zone of another galaxy. The Goldilocks zone is the exact proper distance from the star like the sun, where the temperature is perfect for the water to stay liquid. It's the rule scientists search for when looking for other planets that can sustain life. We can try setting new colonies on one such planet, or even try to set up our own artificial home, not exactly a planet or a spaceship, but a combination of both. Something huge built right in space, say a wheel with gravity everywhere we go, so we don't fall off. It would float in space toward the new exoplanet, capable of fitting entire states in. This whole trip might happen just because the sun first grew too much, and then, having reached the culmination of its life cycle, it would finally become a white dwarf. It's going to be a pretty long journey, and entire generations will be born here. You'll have a choice: sleep your way through the journey until humans finally reach their new exoplanet, or enjoy the trip in this fantastic spaceship. There's all you need on board: malls bigger than those on Earth, large futuristic cities, even places to farm, fields with rich soil made artificially, and finally, after a long journey, the exoplanet. It's even somewhat better than Earth. The planet is giant and has more continents. The continent's center isn't as far from oceans, which means there aren't as many desert areas. Though the sun of this planet is an orange dwarf, it's not as hot as our yellow dwarf sun today. It's a bit smaller, but here's the kick: orange dwarfs live somewhat longer. They remain stable for between 15 billion and 45 billion years. Despite that, this new planet is full of rainforests because the planet itself is warmer. It means more biodiversity and creatures we've never seen before. But even if nothing out there is suitable, we could try and terraform this planet instead. If we take Mars as an example, we could create a greenhouse effect by smashing ice-rich comets and releasing ammonia in them, making the planet warmer. We could also start planting trees. We'd probably need some Earth soil to do that, or we'd have to modify Mars's soil to be similar to ours. Sooner rather than later, the atmosphere would be close to the one we have on Earth. We'd be able to breathe too, because of the trees. Then, we can melt Mars's polar ice caps and voila, water. The problem is the solar winds and sun explosions that might strip it of an atmosphere just as quickly as we can create one, if not faster. It has no magnetosphere either, which means it can't protect us from radiation, so long-term Mars wouldn't be a good choice. Maybe out there, in the vastness that is space, there is a perfect planet waiting for us. For thousands of years, people knew only about the planets Mercury, Venus, Mars, Jupiter, and Saturn, which they could see using simple telescopes, or even by the naked eye if conditions were good. But in the late 18th century, a famous astronomer named Sir William Herschel discovered a new planet that was icy blue in color. At first, people thought it was a star, but later they realized it was a planet. Today, we know it as Uranus, a planet that's more than 19 times farther away from the Sun than Earth. It's so far away that it takes Uranus 84 years to complete one trip around the Sun. This astronomer also discovered many other interesting things in space, like double stars and nebulae. In the mid-1800s, scientists noticed something pulled Uranus and strangely tugged its orbit. They thought there must be another planet out there, and they used math to predict where it would be. Finally, in 1846, they found Neptune using a telescope. It was too faint to see with the naked eye because it was too far away from the sun. It was all so exciting. Who knows how many other planets could be there, lurking in the darkness of our solar system? Back in the mid-1800s, astronomers noticed something unusual was happening in the sky. A small rocky planet named Mercury was behaving strangely. It didn't follow the predictable orbit that was expected of it. One of the astronomers was a brilliant French scientist named Urbain Le Verrier. He came up with a theory that there could be another planet in our solar system no one had yet discovered. It would be located somewhere between Mercury and the Sun. This hypothetical planet, which he named Vulcan after the Roman god of fire, would have an incredibly hot surface, and it could be a potential explanation for Mercury's strange behavior. He never surely claimed Vulcan was really the one thing disturbing the orbit of Mercury. But, excited by the possibility of discovering a new planet, astronomers all over the world took the idea of Vulcan. For a planet that didn't exist, people committed to developing ideas and getting information about it. Some scientists didn't think it was likely that they had missed another planet as big as Mercury. It would have been hard not to see it by then. But there was a tiny chance of a smaller planet existing inside Mercury's orbit that was too close to the Sun, so no one could see it. One theory said it was about 13 million miles away from the Sun. Mercury is the planet with the most eccentric orbit in our solar system, but the closest point it gets to the Sun is about 28.5 million miles. This means Vulcan would be under half of that distance. The theory moved on, saying that if Vulcan existed, it would orbit the Sun every 19 days and 18 hours, and its path would be tilted about 12 degrees relative to the path of other planets in our solar system. Vulcan's position at its furthest point from the Sun would still be too close to the Sun to be seen with the naked eye, even during twilight. The only chance of seeing Vulcan would be during a solar eclipse, or when it passed in front of the Sun, which, as the theory said, would be 2 to 4 times a year. They had a theory that this mysterious planet was so close to the Sun that it could only be seen during a total solar eclipse when the moon blocked out the Sun's blinding glare. So, every time there was an eclipse, scientists would peer at the Sun, hoping to catch a glimpse of Vulcan. They were trying really hard, but no matter what, they couldn't find this mysterious planet. Some astronomers claimed to have spotted it during eclipses, but no one could ever confirm or find evidence for that. The theory of Vulcan was left waiting for some better times. Einstein had a different idea. You know about his theory of general relativity, right? That's where he claimed gravity wasn't some sort of natural force, but a result of space-time curved because of the presence of giant space objects, like planets and stars. Planets circle around the Sun in their usual orbit because space-time is curved. That means the planets are kind of falling towards the central star of our solar system. And Einstein tried to explain Mercury's unusual orbit using his own theory of relativity. Unlike the other planets in our solar system, Mercury's orbit wasn't that circular. Instead, it seemed to wobble slightly, as if there was an invisible force pulling it away. Einstein said this could be happening because the massive gravity of our Sun was actually curving the fabric of space-time around it. He claimed it's possible this changed Mercury's orbit a little bit. It took the scientific community a while to test this theory, but it eventually seemed like the most plausible explanation. Even though Einstein's theory gave us a more elegant explanation for Mercury's strange orbit, some scientists were still holding out hope for Vulcan. It was especially hard to let go of the idea of Vulcan because Mercury is also the planet that's really hard to see from where we're standing. But later, more and more scientists started accepting Einstein's theory above their imagination. And they would observe a total solar eclipse specifically to test Einstein's theory of relativity, not because of Vulcan. And Vulcan is not the only hypothetical planet everyone was talking about. In the newer age, some believe there could be a mysterious planet lurking in the outer part of our solar system. But this one is more likely to exist. No one has seen it directly yet, but computer simulations show this so-called Planet 9, or Planet X, is probably somewhere there beyond Neptune. Neptune and Planet X could be similar in size. Planet X could be 10 times more massive than Earth and circles around our Sun in an elongated shape, which is on average 20 times farther from the Sun than Neptune. A year there may last between 10,000 to 20,000 Earth years. By comparison, a year on Neptune lasts 165 Earth years. Something this big moving out there beyond Neptune could explain the unusual orbits of smaller objects in the Kuiper Belt. The Kuiper Belt is the area of our solar system beyond Neptune and where it orbits. And there are most likely many asteroids, comets, and some other smaller bodies there, mostly made of ice. There was another hypothetical planet called Nibiru. Remember those rumors that the world could end back in 2012? One of the popular scenarios was Nibiru, which some claimed would hit our home planet at the end of the year. Of course, nothing happened. We're still here, all set and good, but the idea of Nibiru seemed interesting. Stories started in the 1970s when a man named Zecharia Sitchin mentioned Nibiru in his book, The 12th Planet, claiming it orbits the Sun every 3,600 years. But there's no chance a planet with such an eccentric orbit wouldn't disrupt other planets in our solar system with its gravity. And if it was really coming that close to Earth in 2012, we were supposed to be able to see it with the naked eye. Some simple calculations showed Nibiru would have been nearly as bright as Mars at its dimmest and brighter than the faintest stars you see from a city. Oh well, maybe we'll have more luck in the next 3,500 and something years. In 2011, a comet named Elenin appeared that many people thought could be Nibiru. But when you're looking at comets and planets through a telescope, you see they appear differently. A comet has a coma, which is a gas atmosphere, together with a tail, something a planet doesn't have. Plus, this comet didn't slam into the Earth. It came too close to our Sun and fell apart. The leftover pieces will continue moving on their way to the outer solar system for the next 12,000 years.
Consider the rogue planet, the cosmic wanderer that nobody wants to take home. Basically, a rogue planet is a planet that has been ejected from its own star system and is now floating aimlessly through space like a cosmic loner. These planets aren't just a theory. Scientists have actually detected some in our galaxy. In fact, estimates suggest that there may be lots of these cosmic nomads floating around the Milky Way. And they aren't just small rocky worlds like Earth. Some of them are actually massive gas giants, many times larger than Jupiter. These behemoths could potentially have their own moons, and even their own mini-systems orbiting around them. For example, one of the most famous rogue planets we know of has a complicated name. Here, you read it for yourself. It's located about 80 light-years away from Earth, and it was discovered in 2013. This rogue planet is estimated to be around 6 times the mass of Jupiter and is believed to be around 12 million years old. And yes, just because these cosmic loners don't have a star, it doesn't mean they're super cold. They can still generate heat and light from their own internal processes. Some may even have magnetic fields and auroras, just like Earth. In other words, rogue planets could potentially be habitable if they have the right conditions. So, what would life on such a planet look like? And could we potentially live in such a world? Well, living on a rogue planet can be a lonely existence. They have no warm sun to bask in, no cozy atmosphere to cuddle up in, and no cosmic neighbors to have barbecue with. That's why we'd have to get creative. Let's start with the most obvious problem. We'd have a hard time without light and heat. So, how do we fix this? Well, we'd probably have to invest in some really fancy space heaters and wear fashionable super-warm spacesuits. Or we could invent a whole new way to generate electricity without relying on solar power. For example, how about using geothermal energy? Now that's hot stuff. Each planet has an internal source of heat. Without it, they would all be nothing more than cold, lifeless rocks floating through space. This internal heat can be harnessed and used to power everything, from homes to factories to spaceships. It's like having a hot tub big enough to power an entire city. And that city, most likely, will be located underground, closer to the heat source. And as for light, well, we'd probably have to build some really bright flashlights. Or maybe even learn to genetically engineer some bioluminescent organisms to light up our homes. Just imagine, space is overgrown with neon mushrooms and plants. By the way, speaking of plants, plant life would be pretty hard to come by without a star. So, what would we eat? Well, we could use the same geothermal vents that we talked about, or some chemical reactions to sustain ourselves. And hey, maybe we'd develop a taste for sulfur-rich foods, or we'd start fermenting our own drinks from the bubbling volcanic mud. Yum! But besides food, we'd have a more important problem. Living on a rogue planet would be breathtaking, literally. We'd have no air. You see, not all rogue planets have good, stable atmospheres. It all depends on their size, composition, and other things. But even if our new home does have an atmosphere, it may be incredibly thin and unstable. We'd have no pretty blue skies or dramatic sunsets to admire. Instead, we'd be staring out into the infinite void of space, where the stars would be brighter than ever before. And forget about weather patterns. Without an atmosphere to create them, we'd have no rain, no snow, and no thunderstorms. And that's just some minor problems. What's worse, the temperature on the planet would be wildly fluctuating, swinging from unbearable heat to unbearable cold. It would be like living in an oven that's always being turned on and off. And finally, we'd be exposed to all kinds of space debris and cosmic radiation. So, if you don't want to get crispy, you might want to invest in some serious SPF. So, how do we fix it? Well, we'd have to find a way to generate our own oxygen and probably create something like a space-age biosphere. For example, we could grow some plants that could produce oxygen, or we'd learn to filter the air like a high-tech air purifier. Finally, we have the last most important problem, finding water. And here's where the underwater oceans come to our aid. Now we're really diving deep into the possibilities. Nyuk nyuk. But seriously, scientists suggest that some of these planets may indeed have underwater oceans. It would be like living on a giant water balloon that's been buried underground, with the ground beneath your feet made of ice and rock. In other words, we could just tap into these underground oceans. They could provide us with a source of water for drinking, farming, and manufacturing. Maybe even with some other resources and materials we've never seen before. And by the way, who knows what kind of strange creatures might be lurking in those underground seas? But don't worry, even if we don't have any underground oasis, there are also other options. We could get some water from comets, ice mining, and even from the atmosphere, the one we just created before. Finally, we need to find and mine some resources to build our homes and other stuff. And a rogue planet might not have the same kinds of resources as a planet that orbits a star. It's like trying to find some treasures in a desert, not exactly a sure thing. We may have to rely on resources from nearby asteroids and things like that. And if we want to extract resources from the planet itself, we might need to drill down through miles of ice and rock. But hey, if you're up for the challenge, there'll always be a chance you'll strike it rich on a rogue planet. And who knows, maybe you'll discover some new resources that are even more valuable than gold or diamonds. Great! Looks like we've solved the most important problems. Now, there may be other small difficulties. For example, we'd also have to deal with some seriously long days and nights, depending on how fast our planet was rotating. And we wouldn't have a normal, regular day-night cycle. The rotation of our planet could be wildly unpredictable. Maybe we'd have weeks-long nights, followed by weeks-long days, which could really mess with our sleep schedules. We might have to develop some really strong coffee to keep us going through those long, dark nights. But, hypothetically, we can adapt to all these things and overcome all the challenges. And now, finally, welcome to the rogue planet, where the sun never rises, but the adventures never end. Thanks to our advanced technology, we've managed to create a comfortable and habitable environment in this once barren world. The sky above us is now a beautiful shade of blue, filled with fluffy white clouds and the occasional flock of flying creatures. Don't ask. As we venture out from our underground habitats, we're greeted by a world that's full of surprises. Strange plants and animals have adapted to the unique conditions of this planet, some with bioluminescent features that glow in the dark. And be careful if you want to go swimming in the underground ocean. They might be home to some bizarre creatures who want to feast on… well, we'll come back to that. Maybe. As you can see, we've created sprawling cities and thriving communities, powered by the planet's geothermal energy. We also created a bunch of artificial light sources that keep things bright throughout the dark, chilly nights. Of course, we still have some problems with navigation and timekeeping, but things aren't as dull as they used to be, are they? Overall, living on a rogue planet would definitely have its challenges, but it could also be a pretty exciting way to experience the universe. And who knows? Maybe someday we'll find such a planet and actually turn it into a bustling intergalactic metropolis someday. But until then, let's enjoy and tidy up our dear Earth.
In a star system far, far away, to be more precise, 2,600 light-years away, there's an exoplanet called Kepler 1658b. It's a gas giant that resembles our Jupiter. But what differentiates it from Jupiter is that this poor planet is doomed. It's spiraling toward its parent star, which will eventually end in a fiery collision. But the most interesting thing? Astronomers would have remained totally ignorant of this fact if not for a tiny clue. It was a really minuscule change in the planet's orbit. It wouldn't have been noticed if astronomers hadn't compared more than a decade of data received by different telescopes. More precisely, scientists have been watching the exo-Jupiter pass between our planet and its parent star once every 2 weeks for the last 13 years. And they've noticed that the orbit of the planet is getting smaller and smaller. Every year, Kepler 1658b needs 131 milliseconds less to complete a lap around its star. If this tendency continues, the planet is bound to collide with its star in 2.5 million years. Even before this discovery, computer models predicted that some planets could meet their end by crashing into their stars. But this is the first time when astronomers have some real proof of such an outcome by measuring almost imperceptible changes in a planet's orbit. They now know for sure what happens when a planet is going to crash into its star, even though we probably won't be around to witness it. But let me tell you a bit more about the doomed planet. It was discovered by NASA's now retired Kepler Space Telescope. It was launched in 2009, and its mission was to find planets orbiting other stars, aka exoplanets. And the very first exoplanet the telescope spotted was the very gas giant we've been talking about. But it took astronomers about a decade to confirm that this space object was indeed an exoplanet. This world is like a denser version of Jupiter. I mean, take 6 Jupiters worth of material, roll it into a ball about 1.1 times as wide, and voila! The planet is tidally locked to its parent star, which means that it makes one complete turn every time it finishes a lap around the star. As a result, the same side of the gas giant is always facing the star. It's the same as what happens to the Moon. Our natural satellite is tidally locked to Earth. That's why we only see half its surface. Now, what is making the exo-Jupiter fall into its star? The same process that is pushing the Moon away from Earth. When a moon orbits a planet, or a planet orbits a star, their gravity forces interact and tug on the other's mass. That's what causes tides on Earth. This tugging releases some energy. It can make an object speed up and slow down. In the first case, a space body will move higher. In the second, it will start moving lower. And this is exactly what's happening to the gas giant. Its parent star is 1.5 times the mass of the Sun. So, no wonder its tidal forces are gradually slowing down the planet's movement, making it fall inward. This all sounds kind of tragic, but this potential collision is by far not the weirdest thing happening in space. Let's look at some others. For example, Betelgeuse, a red giant in the Orion constellation, started to dim in 2019. This confused astronomers. By that time, the star had already swollen to enormous proportions. If it was to replace our Sun, its outer surface would spread far beyond Jupiter's orbit. And then Betelgeuse became dimmer in the fall of 2019. This process continued through February 2020. The changes could be seen with the unaided eye. No wonder, the star's brightness had dipped by 2/3. At that time, astronomers were sure Betelgeuse was about to explode into a supernova. They continued to observe the star, but unexpectedly, it returned to its regular brightness. Thanks to the Hubble Space Telescope, scientists figured out that the star had ejected some of its material, and this partially blocked its light. How about cotton candy exoplanets? Those are particular planets outside of our solar system. Also called superpuffs, they have the lowest density ever discovered. This gives them an airy, fluffy appearance. But despite looking like the most popular amusement park treat, such planets are enormous. Come to think of it, scientists often discover strange things in space. Some of them look like blurry blobs. But there's one type of these blobs that doesn't look like any other known space body. The odd radio circles are only visible in radio telescopes. They might be the remains of supernovae, but some astronomers go as far as to claim that they might be the throats of wormholes. Those are hypothetical tunnels between two very distant points in space. The Juno mission noticed something weird in the upper atmosphere of Jupiter. The unusual phenomenon was blue sprites and elves twirling above the planet's surface. These are two kinds of bright flashes of light that appear for short periods of time, mere milliseconds. They extend up and down toward the surface of the planet. On Earth, such flashes usually happen at the height of 60 miles above massive thunderstorms. Rogue planets don't orbit their stars, maybe because they don't have any. These free-floating space bodies travel across the universe and can end up literally anywhere. They're also pretty hard to find. Rogue planets produce only weak emissions, but not so long ago, astronomers spotted the smallest rogue planet in the Milky Way. It's smaller than Earth, but a bit bigger than Mars. Fast radio bursts are blindingly bright bursts of radio waves. They pack as much energy as our Sun produces in days, but last mere milliseconds. Most of these fast radio bursts come from far, far beyond the Milky Way. But recently, astronomers have detected some originating in our home galaxy, and their source is a magnetar just 30,000 light-years away from our planet. If it does exist, nuclear pasta is the strongest material in the entire universe. Formed from the leftovers of extinguished stars, this substance gets squeezed into spaghetti-like tangles of material. It can break, but only if you apply 10 billion times the pressure needed to shatter steel. Not so long ago, scientists discovered that one of the most massive stars in the neighborhood had just disappeared. It was a star 75 million light-years away from Earth. Normally, it'd be too far away for astronomers to clearly see individual stars, but only unless they're huge. And the star we're talking about was enormous. It was shining 2.5 million times brighter than the Sun. For the last time, astronomers saw the star in 2011. They decided to examine it more closely several years later, but it was already too late. The star had vanished. Such massive stars usually go out in extremely bright supernovae, but astronomers noticed nothing like that in this case. There's a theory that the star collapsed into a black hole without triggering a supernova first. It does occur among stars approaching the end of their lives, but very, very rarely. There are black holes, and there might be mini black holes, even though their existence hasn't been proven yet. Unlike their massive siblings, hypothetical mini black holes could be really tiny. not bigger than an atom. Their mass can vary, but just one minuscule thing might have the mass of 1,000 sedans. One theory claims that tons of micro black holes could have been created right after the Big Bang and the beginning of the universe. Some scientists even go as far as to say that a couple of mini black holes pass through our planet every day. More than 7,000 light-years away from Earth, there is the Eagle Nebula, a young cluster of stars just 5.5 million years old. The Hubble Space Telescope managed to take an image of several dark silhouettes near the nebula's center. Those are the so-called pillars of creation, an active star-forming region. Look, how cool is that?
TRES-2b, or not to be, is a planet where night never ends. And it's not your regular night with stars shining in the beautiful skies. Here it's pitch dark and scorching hot. TRES-2b is a gas giant, roughly 1.5 times more massive than Jupiter, and its surface absorbs light better than charcoal. It might also have a faint dark red glow because of its burning air, which is as hot as fresh lava. Lovely. In the star system of 55 Cancri, there are 5 planets, 4 of which are gas giants similar to Jupiter and Saturn. But the 5th one, or rather the first because it's closest to the star, is different in a most horrible way. 55 Cancri e is so close to its sun that half the planet's surface is a literal ocean of molten lava. The other half is in eternal darkness because it never sees the sun. The planet is always turned to its star on one side, and between the scorching and the dark, there's the twilight zone, a thin strip of gloomy nothingness. That's a getaway spot. HD 189377b, oh, I'm not going to say that again, is the only exoplanet in the orbit of its star, and at first glance it looks quite pretty, blue and white swirls making up wondrous patterns on the surface. But these pleasant colors actually come from hard silicate particles in the planet's atmosphere, which means it rains glass here. But the worst is that winds reach the speed of 5,400 miles per hour, or almost Mach 7. Well, for comparison, the fastest wind speed on Earth was 254 miles per hour, over 20 times less. Thus, the glass falling from the sky travels horizontally at hypersonic speeds, shredding everything in its path. Better duck. The next system, whose name I won't even try to pronounce, this one, has 3 exoplanets, which are all being slowly destroyed by their own star. It happens because that star is not a regular. It's a pulsar, a rapidly spinning core of an exploded star. It creates powerful electromagnetic pulses in several directions while rotating at several thousand times per second. As a result, the planets orbiting this deceased star are slowly being eaten away and will eventually disappear entirely. Kepler-70, hey, I can say that one, is a hot blue dwarf star that exploded into a red giant some 18 million years ago. At the time, it was orbited by at least 2 planets, the closer of which was a Jupiter-like gas giant. Its name was Kepler-70b, and it still exists, but the overgrown star consumed it and transformed it into a blazing hot rocky world. Right now, it's one of the hottest planets ever discovered. Its temperature is higher than the surface of our Sun. It was lucky to survive spending time inside the star, but it's evaporating now and will probably be no more in the near future. WASP-12b is one of the weirdest and saddest planets out there. The enormous gravity of its star, combined with the planets consisting mostly of gas, result in the star slowly devouring its protege. So pal, what's eating you? My mother. WASP-12b has already taken the form of an egg, stretched toward its merciless sun, and it's unable to do anything with its condition. In another 10 million years, the planet will inevitably succumb to the voracious star's appetite. Hey, you asked. If you ever wondered what it's like to walk on ice and hot coals at the same time, Gliese 436b is a planet that would give you a vivid example. Being extremely close to its sun, the Neptune-sized exoplanet boasts temperatures hotter than a blazing oven. And yet, it's covered in ice, which burns incessantly. This ice is much denser due to the enormous gravity of the planet, staying solid even under extreme conditions and not melting away. No list of frightening worlds could do without mentioning Venus, the Earth's evil twin. The second planet from the Sun has an atmosphere so thick and full of clouds that its surface is much hotter than that of Mercury. Volcanic eruptions constantly thrash Venus. Its gravity is almost 100 times stronger than ours, and those clouds I mentioned are not made of water but of sulfuric acid, which condenses and rains down on the ground, adding to the inferno. But even if you were brave, or crazy, enough to try to pass through these clouds, you probably couldn't. The winds up there are as strong as some of the most powerful hurricanes back on Earth. Here we have a very long name for a very, very cold planet. Although the host star is not too far away, it's a small and rather cool red dwarf, whose light and heat barely even reach the planet. The temperatures out there fall as low as minus 370 degrees, which is only marginally warmer than absolute zero. The exoplanet is thus dark, gloomy, and covered in eternal ice that never thaws. I thought I thaw that Thumbworth. Still, if it has a rocky core, it might generate some heat, so there's a chance that deep below the frozen surface, some unknown alien things might lurk. Dimidium, located roughly 50 light-years away from our solar system, is a planet hostile to any living thing on many accounts. It's tidally locked to its sun, which means one of its sides is always facing the star, while the other is always turned away. The hot side is heated to over 1,800 degrees, perpetually blown over with winds reaching 600 miles per hour. And that's winter. Well, actually, I don't know that. Despite Dimidium being a gas giant, it has a large amount of iron in it, which melts and evaporates in the atmosphere, creating clouds. And when those cool down, they fall on the surface in the infernal rain of molten iron. That'll test your mettle. Oxygen is usually viewed as an element that might bring life to a planet, but this is definitely not the case for Osiris. Scientists were shocked to find oxygen on this planet, or rather around it, because it's 8 times closer to its star than Mercury is to the Sun. This extreme distance makes Osiris a living melting pot, where anything that could burn will. It's also responsible for a very short orbit of the planet around the star. A year on Osiris is just 3.5 days on Earth. To boot, the atmosphere of the planet is constantly blown and melted away by the heat from its sun. Vacation? Nah, let's keep looking. Karat Exo 3b is neither as hot nor as cold as some of the others on this list, but it's terrifying in its own more insidious way. It's a gas giant similar in size to Jupiter, yet 20 times denser. This makes this exoplanet's gravity weigh down on everything on its surface 50 times more than it would on Earth. Stepping on it would be your ultimate doom, because you'd be immediately crushed by the density of its atmosphere. Karat 7b is another oven-like world. Its day-to-day temperature is over 4,000 degrees. Combined with the rocky surface, it presents an infernal landscape. The rocks on the ground bubble and boil, evaporating in the atmosphere, where they cool down and eventually fall back on the surface in a brimstone rain. The saddest thing about Karat 7b is that it might have once been a gas giant whose atmosphere melted away from the heat, leaving only the scorched core. So, we might be getting closer to finding a massive icy planet beyond Neptune's orbit. Yeah, sorry Pluto, still not you. Recently, some universe mapping using data from a telescope in Hawaii eliminated about 78% of the possible locations for this mysterious Waldo from space. Some people call it Planet 9, while others prefer Planet X. Either way, it's been causing controversy since its existence was first proposed, and that is mainly because no study so far can answer the big question: does it really exist? If discovered, Planet 9 would rank as the 5th largest planet in our solar system, with a mass 10 times that of Earth. It's also theorized to be gaseous, like Uranus. The initial study on Planet 9, dating back to 2016, suggests that this colossal new planet orbits the Sun 29 times farther out than Neptune. which sits at about 2.8 billion miles. As a result, the planet 9 would take between 10,000 and 20,000 years to complete a single orbit around the Sun. If confirmed, this yet-to-be-understood world would dominate a region larger than any other known planet in our cosmic neighborhood. These are all intriguing hypotheses, but without a single piece of evidence or observation to back them up. Before dismissing this as a wild guess, it is important to note that these researchers relied on complex mathematical modeling and computer simulations to speculate about the planet's characteristics, because that's what they do. The hypothetical presence of this planet would explain various mysterious features located beyond Neptune. We are specifically talking about the Kuiper Belt, a huge donut-shaped region filled with icy debris left over from the formation of the solar system, including comets and dwarf planets like Pluto. What happens is that the 6 farthest objects in the Kuiper Belt exhibit elliptical orbits that are all oriented in a similar direction within physical space and tilted approximately 30 degrees downward relative to the orbital plane of our 8 known planets. What's strange here is that, despite their distinct orbital velocities around the solar system, they maintain this alignment. The likelihood of such alignment occurring randomly is extremely low, around 0.007%. So, here comes Planet 9, a hypothetical massive celestial body that offers a plausible explanation for this strange phenomenon, potentially exerting gravitational influence to shape these orbits. The initial theory didn't hold up for long, facing accusations of observational bias and calculation errors. Then, in 2017, another study popped up, sparking back the idea that maybe Planet 9 is out there after all. This time, Spanish astronomers tried a novel approach, focusing on observing extreme trans-Neptunian objects. These celestial bodies orbit the Sun in highly stretched elliptical paths, with average distances exceeding 13 billion miles. The research suggests that the distances between these objects' nodes and the Sun might provide clues to Planet 9's location. You see, these nodes are the points where a celestial body's orbit intersects the solar system's plane. When these objects reach these points, they're more likely to interact with other solar system bodies, potentially causing significant changes in their orbits or even collisions. So, if the trajectory of these extreme trans-Neptunian objects remains stable, everything's fine. But if it's not, well, that's a sign that something else, something big, is messing with their path. And that's exactly what the research found. There is something unseen out there, throwing these objects off course. And that something could be a planet chilling at a distance between 300 to 400 times farther from the Sun than Earth. To this day, the study of the extreme trans-Neptunian objects is the strongest evidence we've got for Planet 9's existence. And if you're still not convinced by this theory, know that strange motions like these have led to planetary discoveries before. Neptune, for instance, was spotted because Uranus's motion didn't quite agree with the predictions of Newtonian gravity. But the deflection of its orbit could be explained if it was caused by a pull of an undiscovered planet. And just like that, we discovered Neptune. Now, the year is 2021, and there's all this buzz about Planet 9 again. After correcting some old guesses, studies are now leaning towards the idea that this mystery world follows an epic loop around the Sun every 7,000 years. That is massive news, because it means this planet might be closer than we ever thought, making it easier for our telescopes to spot it. The paper also suggests there is a whopping 99% chance that the funky orbits of these distant objects are all because of this unseen planet, not just some cosmic coincidence. Now, the odds of this whole situation being a fluke are down to a 1 in 250 chance, which is much better than the 1 in 10,000 chance back in 2016. All these optimistic numbers have brought us to where we are today, keeping our hopes and working on better equipment to continue the mission of spotting Planet 9. As mentioned earlier, researchers in Hawaii created some kind of treasure map utilizing the Panoramic Survey Telescope and Rapid Response System to eliminate 78% of its locations. This is great news, considering how challenging it is to find a planet-sized needle in a cosmic haystack. But unfortunately, Planet 9's presence remains a ghost in the dark outer reaches of our solar system. Enthusiasts are still convinced of its existence and believe it is only a matter of time before we celebrate the discovery of Earth's new cosmic cousin. They're putting their hopes on the Vera C. Rubin Observatory, which is currently under construction in Chile and is scheduled to begin science operations in late 2025. Over the course of 10 years, this observatory will scan the entire southern hemisphere sky every few nights with a 27-foot, fast-moving telescope equipped with the largest digital camera in the world. The idea is to catalog everything in the solar system, reaching out to and beyond Neptune, and tracking the movements of millions of celestial objects, including space junk, asteroids, comets, and stars. If Planet 9 is indeed out there, this next-generation telescope could be the one to find it. The existence of this mysterious planet is far from being universally accepted in the scientific community. That is simply because Planet 9 isn't the only explanation for the strange phenomenon occurring beyond Neptune. One theory suggests that a group of distant objects, such as dwarf planets, comets, and moons, might be collectively influencing the orbits of the extreme trans-Neptunian objects. Others believe that a black hole is behind all this. These compressed masses are some of the densest objects in the universe, potentially capable of affecting the orbits of other masses, like how this supposed ghost Planet 9 is believed to be doing. Another bold perspective suggests that our current understanding of the laws of gravity is flawed, actually incomplete. This theory, known as modified Newtonian dynamics, proposes that these distant icy objects exhibit strange behavior not due to influence from another planet, but rather because the immense gravitational field of the Milky Way is influencing them. However, even supporters of this theory acknowledge that it is too early to draw firm conclusions, and much more extensive research is still required. While we continue our relentless hunt for Planet 9, some astronomers have taken it a step further, suggesting the existence of a hypothetical Planet 10. This world has a mass and size like that of Mars or Earth and is located on the edges of the Kuiper Belt. But the thing is, if this alleged Planet 10 is indeed as small as scientists believe, it might not have enough gravity to clear its orbit of debris. And that is pretty similar to what happens with Pluto, being one of the reasons why it got into trouble back in 2006. So yeah, it's better not to get too excited. This supposed Planet 10 might end up classified as another dwarf planet. Let's see, there's Mercury, Venus, Earth, Mars, Phaeton, Jupiter. Wait, hold on, what Phaeton am I talking about? Well, let's see. It was the beginning of the 19th century, and the asteroid belt hadn't been discovered yet. In the year 1801, one man named Giuseppe Piazzi spotted the largest asteroid in the solar system, Ceres. At that time, people believed that there was a planet orbiting between Mars and Jupiter, and Ceres seemed to fit the bill. But the next year, another astronomer, Heinrich Olbers, found one more space body following a similar orbit. It was an asteroid which was later called Pallas. This discovery helped Olbers to figure out that these two space objects could be fragments of a planet. The discovery of two more asteroids, Vesta and Juno, seemed to confirm this theory. It was believed that the planet, which was named Phaeton in the 20th century, appeared in the early days of the solar system and was later destroyed, and its debris formed the asteroid belt. Olbers' idea was called the disruption theory. To astronomers at that time, it seemed obvious that the planet once collided with a large space object, which led to its demise. The most likely candidate was Nemesis, a hypothetical red or brown dwarf orbiting our Sun. Another theory claimed that Phaeton could have gone through an internal cataclysm, which could have broken the planet into pieces. There was one more idea. Phaeton could have come too close to Jupiter and got torn apart by the gas giant's immense gravity. These days, though, astronomers don't believe in the disruption theory anymore. A new idea has replaced it. It's known as the accretion theory. It claims that the asteroid belt is all that is left of the protoplanetary disk. Supposedly, this disk had been originally orbiting the Sun, even before the planets formed. Unfortunately, because of Jupiter's gravitational forces, it never managed to coalesce into a planet. But what is this asteroid belt we keep talking about? This region is located between the orbits of Jupiter and Mars. Tons of asteroids and even minor planets are found there. Some of them can sometimes migrate or even get thrown out of the asteroid belt to the outer solar system. The four largest asteroids in that area are Ceres, Vesta, Pallas, and Hygeia. They make up half the mass of the entire belt. As for the rest of the mass, countless smaller bodies make up for it. In loads of sci-fi movies about space, the main character gets into an asteroid belt and has to try hard to get away from countless rocks threatening to smash their spacecraft. Well, it has nothing to do with the real thing. Even though there are thousands of asteroids in this region, they're so widely spaced that the chance of collision is next to nothing. Hey, but it's a movie, right? Anyway, when the asteroid belt was forming, some objects started to come together and form what we know as protoplanets. But the gravitational pull that was caused by the formation of Jupiter made such collisions too rough, and instead of forming large space bodies like planets, asteroids shuddered. Astronomers think that as a result of such collisions, more than 99.99% of the original mass of the asteroid belt was lost in the first 100 million years of the history of the solar system. Only the largest asteroids have enough gravity to get a spherical shape. Small ones are just often piles of rubble, loosely held together by gravity. And the tiniest objects in the asteroid belt resemble dust, so small they are. And all these objects, giant and tiny, orbit the Sun. There are several types of asteroids, depending on their composition and albedo, which is the proportion of light or radiation reflected by a surface. The main types are carbon asteroids, which have a very dark surface, silicon ones, you can also call them stone asteroids, and metal ones. The first two types account for around 75% and 17% of asteroids that we know about. For the first time, the asteroid belt was crossed by a spacecraft in 1972. It was the Pioneer 10 space probe. The spaceship managed to refute the theory that the belt was filled with dust that could easily damage all gadgets on board. It didn't happen. And since that time, 8 more probes have traveled through the asteroid belt. And now, I'm going to tell you some cool facts about the solar system itself. Try to count how many of these facts you've known before and write your answer down in the comments below. The solar system is a staggering 4.5 billion years old. Scientists came to this conclusion after studying meteorites, the oldest material they managed to find. But our solar system isn't the only one in the Milky Way galaxy. The galaxy we live in houses about 100 billion star systems. And if it's just our galaxy alone, what can we say about the whole universe? Now, our Sun is also insanely massive. Here's the proof. 99.86% of all the mass of the solar system is the mass of the Sun, in particular hydrogen and helium that it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. Oh, by the way, contrary to popular misconception, outer space isn't a perfect vacuum. It contains not only stars and planets, but also clouds of interstellar dust, space plasma, and cosmic rays. Those are atom fragments dashing from the outskirts of the solar system. Now, one phenomenon astronauts should worry about while exploring space is cold welding. If two pieces of the same kind of metal touch in space, they bond and get permanently stuck together, kind of like galaxy glue. It doesn't happen on Earth since water and air keep pieces separate. You can see solar eclipses even though the Moon is 400 times smaller than the Sun. It's also 400 times closer to Earth, so it's perfectly capable of obscuring the star. But in 600 million years, the Moon won't be able to block the Sun completely because of the satellite's changing orbit. Behind the orbit of Neptune, there is the mysterious Kuiper Belt, filled with massy icy objects. The most curious thing about this space formation, though, is that the scientists fail to explain the pattern of its movement. The only explanation they have is that Neptune might be hiding a ginormous planet. This hypothetical planet has already got the name Planet 9, and all we have to do is wait until its existence is confirmed, or not. The ocean on Jupiter is larger than any body of water on other planets of the solar system. But it's not the ocean you think about. The one on Jupiter isn't made of water. This mesmerizing thing consists of metallic hydrogen, and its depth is around 25,000 miles, which is actually almost the same as the circumference of Earth. Now, people got to know about beautiful Saturn's rings in the 1600s, but now we know that Saturn isn't the only ringed planet. All the giant gas planets, Uranus, Neptune, and Jupiter, have rings of their own, but they're thin and almost impossible to see. As for Mars, Venus, and Earth, they're made of rocky material and have no rings. At the same time, Saturn's moon Rhea might have a ring system consisting of 3 narrow bands. If astronomers manage to confirm it, it'll be the first time for people to discover rings around a moon. Oh, and Mars might get a set of rings of its own in the next 70 million years. The red planet's largest moon, called Phobos, is orbiting closer and closer to the planet. One day it's likely to get broken apart by the gravitational pull of the red planet and turn into a ring that can last for millions of years. And another cool fact about Mars. You've probably heard of methane gas, a byproduct of such natural processes as volcanic activity and cow emissions. Anyways, this gas is not only a part of the Martian atmosphere, but also the thing that confuses astronomers to no end. The thing is that the volume of methane on Mars keeps wavering, and scientists just can't figure out where it might be coming from. Can there be life on Mars? Can there be cows on Mars?
Have you heard about Planet 9? No, not Pluto. We're talking about something lurking on the outskirts of the solar system. A mysterious planet that exists in our solar system that we haven't yet discovered. We've been looking for it for years, but finally, it seems like scientists found a key to solve this mystery. Planet 9 is a hypothetical planet. Astronomers have been on the hunt for it for quite some time now. But it's so elusive that they've only been able to piece together a few details about its potential characteristics. One thing we do know is that Planet 9 has to be a massive world, possibly up to 10 times the mass of Earth. That's one big planet. It's also thought to be a distant wanderer, hanging out somewhere between Neptune and Pluto. Some scientists think that Planet 9 might actually be a mini Neptune, with a thick, gaseous atmosphere and a rocky core. Others speculate that it could be an icy world with a solid, frozen surface and a thick layer of hydrogen and helium gas. Of course, since we haven't actually found Planet 9 yet, we can't say for sure what it's like. We're not even sure that it even exists. Some say it's just a myth, like the Tooth Fairy or the Easter Bunny, but others are convinced that it's out there somewhere. And at the end of the day, we're not entirely sure if Planet 9 is even a planet. It might be a special kind of black hole or made entirely of dark matter. The search for Planet 9 began in the early 21st century when a group of astronomers realized that something wasn't quite right with the outer reaches of our solar system. They noticed that some distant objects, known as trans-Neptunian objects, were behaving in unexpected ways. Trans-Neptunian objects, or TNOs, are like the cosmic version of those items in the back of your fridge that you forgot about for years. They're small, icy bodies that hang out in the Kuiper Belt, beyond Neptune. So, scientists noticed that these guys started behaving weirdly. At first, they thought it might be a fluke, But as they dug deeper, they began to suspect that there was a ninth planet lurking out there. Why haven't we discovered it yet, you ask? Well, it may be because of Planet 9's weird orbit. All the other 8 planets orbit the Sun in roughly the same plane, which is like a flat disk. However, our hypothetical friend's orbit is different. It might be tilted and move in a different direction compared to the other planets. Its orbit might also be stretched out like an oval, rather than being nearly circular like usual. Because of this, Planet 9 might spend most of its time far from the Sun, like a true introvert. It only comes relatively close to the inner solar system every few thousand years. This would make it super faint and hard to spot, so the only way we may discover it is by studying the gravitational effects it has on our solar system. And this isn't the first time astronomers have gone looking for a new planet. Back in the 19th century, there was a similar hunt for a hypothetical Planet X. But this time, they were armed with much better technology and a much better sense of humor. They began calling their elusive quarry Planet 9, which was much catchier than Planet X. They even came up with a hashtag for the search, Pluto Lives. It was a reference to the fact that Pluto had been kicked from the planet gang, and some astronomers were eager to find a new planet to take its place. But the search for Planet 9 has been no easy task. It's like trying to find a lost sock in the laundry basket the size of a football stadium. It's so far away and so faint that even the most powerful telescopes can't see it. Instead, astronomers have had to rely on indirect evidence, like the strange orbits of TNOs, to try to figure out where it might be. Some scientists have even supposed that it might be a wandering rogue planet, which would explain why it's so hard to find. But they haven't given up hope. Till this day, they're scouring the skies using all sorts of high-tech telescopes and fancy algorithms to try and spot this elusive planet. And fear not, dear curious human, because it looks like after so many years of research, we may have finally found the key to solve this mystery. Astronomer Man Ho Chan from Hong Kong has a theory. He believes that Planet 9 could have a bevy of moons. That's right, not only is it a giant planet hiding out in the depths of space, but it's also a bit of a hoarder. Moons are all the rage in the outer solar system. In fact, almost every planet here has at least one moon, except for Mercury and Venus. Earth has just one, which is kind of sad if you think about it. Even non-planetary bodies like Pluto have at least a couple of moons. A bit unfair, isn't it? Anyway, taking this into account, let's go moon picking with Planet 9. The region between the rock-filled Kuiper Belt and the rock-filled Oort cloud, where this planet is predicted to be, should be ripe for the picking. Chan made some calculations and determined that it would be stranger if the elusive planet didn't have any satellites. According to his calculations, an object the mass of Planet 9 should capture at least 20 TNOs as large as almost 90 miles across. It's like our mysterious planet is playing cosmic Pokemon with these guys. So, what if Planet 9 has moons? Would that make any difference? Kinda, yes. They could give us some indirect clues to finally locate this mysterious planet. Now, you might be thinking, how in the cosmos can we possibly spot these teeny tiny moons? It's not like they're going to wave a giant flag or blast some Beyoncé tunes to get our attention. Well, apparently the key lies in something called tidal heating. Tidal heating might sound like a new workout trend, but it's a real scientific phenomenon. It happens when two celestial bodies are close together. You see, tides aren't just about the rise and fall of the ocean, they're also the result of gravity pulling unevenly on a planet or moon. When a planet and a moon are close enough to each other, their gravity pulls on each other, creating a bit of a football shape. And as these celestial bodies move around each other, they shift shape and generate friction inside, which produces heat. Wow, who knew that Planet 9 could have a workout routine? Perhaps we should start calling it Gym Planet instead. Anyway, if Planet 9 has any moons, the gravitational pull from these moons would cause it to change shape constantly, generating heat in the process. And we might be able to detect this mysterious planet through the heat produced by those moons, even though it gives off no other signals. Now, before you get too excited, finding them won't be a walk in the park. They're incredibly small and would be very far away from us. But hey, nothing worth discovering ever came easy, right? Scientists are optimistic that with the right technology, they can spot this telltale sign. It will be easier for us to spot them with fancy instruments like modern telescopes. Talk about cool friends to have, right? Sure, the process of finding it may be difficult and time-consuming, but the potential payoff is huge. Finding this planet could explain a lot of the strange behavior observed in TNOs, the Kuiper Belt, and beyond. As we've already mentioned, they've been acting super weird lately, tilting and aligning in suspicious ways. If this planet doesn't actually exist, we have yet to explain what is the reason for this strange behavior. In any case, the search for Planet 9 is one of the most exciting and intriguing quests in modern astronomy. It's like a cosmic scavenger hunt, and everyone's invited to join in on the fun. So, grab your telescopes and let's go planet hunting. Who knows, maybe we'll find it sooner than we think.
Uranus is an enigmatic giant that has puzzled astronomers for centuries. But what sets this gas giant apart from the others is its strange tilt. While most planets spin on an axis that is perpendicular to their orbit, Uranus takes a wild spin in a different direction. But why does it look like this? How did the planet turn out to be lying on its side? And what would we see if we visited the surface of such a planet? Let's find out. Uranus, the seventh planet from the Sun, is a cosmic oddball and source of many jokes. It's one of the gas giants in our solar system, along with Jupiter, Saturn, and Neptune. It's also the third largest planet in our solar system, with a diameter of about 31,000 miles. And one of its many oddities is a weird rotation on its side. Not all planets in our solar system are aligned in a straight line. While most planets in our solar system have an axial tilt of less than 30 degrees, Uranus is tilted at an angle of almost 98 degrees. It's like that one friend who always has to be different, even if it means standing on their head to prove a point. So its north and south poles are facing east and west. It's like the planet got lazy and just rolled over one day, deciding to take a nap. And why is Uranus so tilted, you ask? Scientists once thought this was due to some kind of collision. They thought that something gigantic crashed into Uranus, something like what happened to our Earth. A dwarf planet crashed into it, the Earth tilted slightly, and the Moon was born from the remnants of the collision. But this theory had a problem. In the early universe, there were a bunch of asteroids, dwarf planets, and other large objects. And if this is so, then why is only Uranus tilted? All sorts of guys have crashed into other planets too, but they don't have such features. But recently, scientists have published a new study, and now scientists think that the culprit might be a long-lost moon that wandered away. Back in the days of the early solar system, the giant planets partied much closer together and way closer to the sun. But, as we all know, parties can get out of hand. Something caused Uranus and Neptune to migrate the farthest, like they were trying to get away from the sun's strict supervision. Each giant planet had a collection of moons, but they were constantly getting shuffled around during all this migration madness. Some planets lost moons, while others gained new ones. Uranus could have been born with a massive moon, or quickly captured one, and if that moon was big enough, it could have started playing games with Uranus's spin. This moon pulled on Uranus with its gravity, making the wobbling even worse. As time went on, it made Uranus tilt more and more. Eventually, it crashed into the planet, locking it into its current tilt. While the theory is pretty sound, based on computer models, we'll have to wait until at least 2030. That's when China plans to launch the Tianwen-4 spacecraft to take a closer look at Uranus and study it more. Who knows what other crazy space secrets we'll uncover next? Until then, we can all have a good laugh about the lazy, rebel planet that just can't seem to stand up straight. Such a funny and unique feature makes you wonder, what exactly would we see if we were standing on this planet? How would its strange tilt affect the view from its surface? Let's see, if you were standing on the surface of Uranus, although it doesn't really have a surface, it's more like a gas atmosphere, you'd enjoy a cool view. You'd see the sun rise in the east, just like on Earth, but then it would keep going around the sky in a tilted path, like a lazy spiral. About the sunset though, I hope you have some patience, because it would take 42 years for the sun to complete one full circle around Uranus's sky. That's a really long time to wait before finally going to bed. But speaking of the sky, it would be a beautiful sight to behold. Uranus is known for its stunning, unique blue-green color. It's caused by the methane gas in its atmosphere. Methane absorbs red light, giving Uranus its cold hue. You'd also see some amazing clouds and storms swirling around the planet. But if you're looking for constellations, you're out of luck. The extreme tilt of Uranus means that its poles face towards the sun, so the stars would be all over the place in the sky. The constellations that are familiar to us would be unrecognizable from Uranus. Also, as the planet rotates, the position of the stars would change very often. For you sailors out there, good luck in navigation. But you could see its beautiful moons. Uranus has 27 known moons, with the largest being Titania, followed by Oberon, Umbriel, Ariel, and Miranda. These moons are thought to have formed from the same material that formed Uranus, and yes, the tilt affects them too. They orbit around the planet perpendicular to the planet's motion around the sun. And they aren't the only ones. Did you know that Uranus also has rings? Yeah, not only Saturn is so special. The rings are made up of ice particles, some as small as grains of sand, and others as large as several feet across. They're thin, narrow, and dark compared to Saturn, for example. They're actually so black that they almost don't reflect the light. That's why it's so difficult to see them from Earth. But if you were near the surface of Uranus, you might be able to see them in the sky. The only question is, would you even be able to focus on all these views? Because Uranus is extremely cold, and that will probably be the only thing you'd think about. We're talking about temperatures that can drop down to negative 350 degrees Fahrenheit. Brr, better pack some warm clothes for this trip. This is because it's so far from the sun, and its atmosphere is composed mainly of hydrogen and helium. And not only is Uranus the coldest planet in our solar system, but the winters there are long. Due to the extreme tilt, it has seasons that last for over 20 years. It's like the planet is stuck in a perpetual state of winter, which is both cool, pun intended, and kind of sad at the same time. And if that's not cold enough, Uranus is also known for its strong winds. In fact, they can blow up to 360 miles per hour. So you might want to hold on tight to something, or wear a windproof suit to avoid being blown away like a leaf. And finally, Uranus's magnetic field is also tilted at an angle of 59 degrees from the planet's axis of rotation. This creates some interesting effects. The most obvious one is beautiful auroras, which are similar to the northern and southern lights on Earth. On Uranus, however, the auroras are located near the planet's equator rather than at the poles. Isn't that cool? The result is a dazzling light show that would make even the most jaded space traveler stop and stare in wonder. But even though it sounds pretty awesome, it makes it more difficult for spacecraft to navigate around Uranus. The magnetic field creates a lopsided gravitational pull that can affect the trajectory of spacecraft. This makes exploring Uranus a bit more challenging, but maybe it will change in the future. All in all, standing on Uranus would be a chilly, wobbly, and breathtaking experience, and definitely not your average stroll in the park. Next time you look up at the night sky, think of this beautiful icy planet, and remember that even in the vast expanse of space, there is always something new and exciting to discover. I hope you feel well rested, because I've got a tough task for you. Don't worry, it's fun. You're going to visit different planets of our solar system and try to run on each of them. Let's figure out where you can run the fastest and where you can barely walk. The fastest man on Earth, Usain Bolt, can run with an average speed of about 23 miles per hour, but his top speed is higher, up to 27 miles per hour. Sadly, we can't all be Usain Bolts. The average person runs at a speed of 6 to 8 miles per hour. But maybe there's a planet out there where you can beat the famous Jamaican sprinters' records. But first things first, what will affect your speed when you run on other planets? For one thing, gravity. Depending on how strong it is on the planet you visit, it'll influence your weight. And in most cases, the heavier you are, the more slowly you run. Plus, on all other planets in our solar system except Earth, you'll have to wear a bulky spacesuit. Without it, your chances of survival there are non-existent. And don't forget about extreme weather conditions on most planets. It's either freezing cold or boiling hot, or very, and I mean it, windy. Anyway, your amazing journey is about to begin. Buckle your seatbelt. The first planet on your itinerary is Mercury. As you sneak a peek at this world through the window of your spaceship, you notice that the planet looks eerily similar to the good old moon. But just a few moments later, you realize it's just an illusion. All over the surface of Mercury, you see craters left by space rocks. This may make your task of running on this planet way harder. This and your bulky spacesuit. Duh. But you wouldn't survive on Mercury without this protection. The temperatures on the planet are extreme, 800 degrees Fahrenheit during the day and negative 290 degrees Fahrenheit at night. But there's one thing that can work in your favor on this unfriendly planet. Let's say you weigh 155 pounds on Earth. Then on Mercury, you'd weigh around 58 pounds, which means that despite your bulky spacesuit, you can move way faster than you do on Earth. And maybe your speed will even reach 13 miles per hour if you try really hard. The next planet on your itinerary is Venus, also called the Morning Star. While coming closer, you see a world very different from the bluish planet you might have seen in books. Before landing, you have to get through a super dense atmosphere made up of carbon dioxide. And while your spacecraft is descending, you're watching thick clouds of sulfuric acid pass by. Venus is often called Earth's twin because these two planets are of similar size and density. No wonder that on Venus, you weigh almost as much as you do on Earth, 140 pounds. So your weight is a bit smaller here, but don't forget about your spacesuit. And still, because of almost the same conditions on the two planets, you'd be able to run a bit faster than on Earth, at around 8.5 miles per hour. Your first impression of Mars is that it's freezing cold. The average temperature here is about negative 80 degrees Fahrenheit. Even from afar, the planet looks reddish. Once you make your first step on the Martian surface, you understand why. The ground's covered with rusty-colored dust. The same fine dust is floating in the air around you. Wherever you look, you see golden, brown, tan, and even greenish hues. They depend on the minerals that make up the soil. The size of the dust layer varies from area to area, but in most places, it's around 7 feet thick. That can make running much more difficult. On Mars, your weight would be much smaller than on Earth, a mere 58 pounds. This will help you achieve an impressive speed of 12 miles per hour. Aren't you a champ? What's that on the horizon? It looks like a tornado. Is it a dust storm? Then it's time to make a run for it. Dust storms sometimes cover the entire planet, and you can even see the largest ones from Earth. And now you're facing a problem. You see, Jupiter, as well as Saturn, is a gas giant. This means that the largest planet in the solar system, and Jupiter is so large it could swallow 1,300 Earths, doesn't have any solid surface. Well, you'll just have to imagine what your running workout would look like if you could run on Jupiter. This planet has an atmosphere that consists of hydrogen and helium gas. During your descent, you admire thick brown, yellow, red, and white clouds. They make the planet look colorful and beautifully striped. On Jupiter, you'd weigh 390 pounds. You'd have to break a sweat to simply walk there, wearing your clumsy spacesuit. If you could step on the planet's surface, that is. If you tried to run there, your best result would probably be a speed of 1 or 2 miles per hour. To make matters worse, it's extremely windy on Jupiter, with the wind speeds ranging from 200 to 400 miles per hour. Do you see those rings? That's Saturn, another gas giant with no solid surface. This planet's made up of mostly hydrogen and helium, and its temperature and density change the deeper you go. If you decided to leave your spacecraft and step on Saturn's surface, you'd just fall into the planet. But from above, it looks as if Saturn does have a surface. The seemingly solid yellowish-brown sphere is surrounded by several layers of clouds. The visible outer layer is made up of ammonia clouds. Under them, there are hydrosulfide clouds, and the innermost layer is made up of clouds of water. Even though Saturn is a gas giant, your weight wouldn't be very different here, around 165 pounds. That's because the planet's gravity is similar to that of Earth. But because of the conditions on the planet, and your bulky spacesuit, you'd run a bit more slowly there, at a speed of about 4 miles per hour. Before leaving, you admire Saturn's most famous feature, awesome gray, beige, and tan rings. These groups of tiny ringlets are made of chunks of rock and ice. You also spot several of the 53 moons of Saturn. Oh, that's Titan, an icy world bigger than our moon and even Mercury. It's the second largest moon in the solar system. The next planet on your way is a blue-green ball of ice and gas. That's ice giant Uranus. It has this beautiful hue because the light from the sun gets reflected off the planet's surface. Uranus isn't solid. Hit the brakes! If your spacecraft doesn't manage to stop in time, it'll fly through the upper atmosphere and sink into the icy liquid center of the planet. I doubt you'll be able to conduct your running experiment here. So let's just imagine what it'd look like. On Uranus, your weight would be around 138 pounds, and against all odds, you could actually reach a good speed here, at least 8 miles per hour. If you didn't get caught in a hurricane, of course. Extreme storms occur on the planet in the summer when Uranus is heated the most. Then, hurricanes can spread for more than 6,000 miles. The furthest planet from the Sun, Neptune, is 4 times the size of Earth, but 17 times as heavy. The blue surface you see when approaching Neptune is actually a layer of swirling gas and permanent clouds. The planet's mantle is made up of water, ammonia, and methane ices. It's the closest thing Neptune has to a surface. And still, there isn't solid ground for you to walk on. So, once again, try to use your imagination. On Neptune, you'd weigh a bit more than you do on Earth, 174 pounds, but your running speed would be just a bit lower than on Earth, around 5 miles per hour. That's the end of your active adventure. Which planet did you like running on the most? Our universe is full of both amazing and terrifying things. You already know about quasars, black holes, dark matter, and so on. But how about the horrors of space that you haven't even heard of? Would you like to visit the most bizarre worlds in the universe? And it's not me who made this list, but NASA themselves. Welcome to the Galaxy of Horrors, NASA's awesome Halloween collection. Please join me on a journey to some planets and tell me which ones you would consider the most horrible. Buckle up! Our first destination is a gas giant called TRES 2b. It's located 750 light-years away from us. If we used a regular spaceship, it would take us about 10 million years to get there. TRES 2b orbits a yellow dwarf, a star similar to our Sun. It also weighs about 1.5 times more than Jupiter. So, what's so special about it? Well, if you're afraid of the dark, you definitely don't want to visit this place. It's the planet of eternal night, the darkest one of all the planets known to us. But it's not that far from its star, so why is that? The thing is, the surface of TRES 2b reflects light even worse than coal does. Because of this, it seems that there's no light at all. If you were flying across the surface of this planet, it would be like walking with a blindfold on your eyes. Oh wait, actually there is some light. An eerie deep red glow surrounds the surface of the planet. This glow is created by the burning atmosphere, which makes TRES 2b a scorching planet. The air there is even hotter than lava. Oh, but if you think that was bad, let me show you the next place of our horror journey. NASA wasn't beating about the bush while nicknaming this one. Now, we're not just talking about one planet, but 3 at once. They're also located quite far away, 2,300 light years from the Sun. We would have reached them by ship in about 35 million years. All the planets are in the constellation Virgo, and each is extremely light, much lighter than the Earth. These 3 exoplanets are called Poltergeist, Dragger, and Phobator. Cool names, huh? It's because each of these planets is about to become a ghost soon. The thing is, they don't revolve around a star, but around a pulsar. Pulsars are rotating neutron stars with an extremely powerful magnetic field. In simple words, these are the stars that exploded one day. After the explosion, they usually emit such a powerful pulse that it causes the star to rotate at an unimaginable speed, several thousand rotations per second. At the same time, they constantly emit electromagnetic pulses that affect everything around them. So, you've probably already guessed what's happening with our zombie planets. They're slowly, gradually being destroyed under the gigantic influence of radiation. One day, they'll disappear without a trace. Ghost-like planets orbiting an undead star? Yeah, Zombie World is a fitting name. It's also not surprising that scientists nicknamed this pulsar Lich, despite the long official name. Well, at least these guys stick together on their final dance. This planet has a long name, so bear with me. HD 189733b. This gas giant is 65 light-years away from us. It would have taken around 1 million years to get there on a spaceship. This planet is slightly more massive than Jupiter and orbits its star, an orange dwarf, all alone. At first glance, it may seem friendly. A pleasant blue color and curls on the surface. Kind of resembles a summer sky or foam on sea waves, right? Oh, looks are very deceptive, my friend. This planet has a pleasant cobalt blue color due to the hazy blowtorched atmosphere. This atmosphere contains silicates that condense when heated. In other words, the clouds on this planet have rain made of glass. Yes, it rains hot glass shards here. Oh, and if that's not enough, there's a raging wind on the surface, which is moving at a speed of 5,400 miles per hour. Just to compare, the fastest wind on Earth had a speed of 254 miles per hour, about 20 times weaker. And because of this, hundreds of thousands of glass shards rush horizontally across the planet's surface at breakneck speed. I really don't envy anyone who would want to try to land there. By the way, this isn't the only example of strange rains in our universe. For example, it rains molten iron on the planet Dimidium. Or let's take so-called carbon planets. Their existence hasn't yet been proven, but if they do exist, there would be tons of black poisonous clouds, and it would rain pure gasoline and hot liquid asphalt. Oh, and also, raindrops would explode upon touching the surface. Nothing special. The next planet, though, is actually really strange. It didn't just revolve around its star, it lived inside the star. This cosmic miracle is called Koi 55b, or Kepler 70b. This planet is very far away from us, 4,000 light-years. It would take about 70 million years on a spaceship. It's twice as light as Earth and fully rotates around its star in just a couple of hours. A long time ago, it was an ordinary Earth-like planet about the size of Jupiter. It was peacefully and calmly orbiting its red dwarf star, Koi 55. But everything changed about 700 million years ago. Perhaps you've heard that in a couple billion years, our sun will begin to expand into a huge star, absorbing everything in its path. Well, this is the fate of red dwarfs. Sooner or later, they increase, turning into incredibly hot blue giants. The same thing happened with Koi 55. This star began to increase in size and heat up in temperature, gradually turning into a blue-white giant. It was ready to devour its nearest planets. But Koi 55b didn't care about it. When the star reached it, this planet just settled inside. And moreover, after some time, it left its star, simply returning to the new orbit. How was that even possible? Life inside its star turned Koi 55b into a red-hot round stone. It's one of the hottest planets we've discovered so far. The temperature on it reaches 12,000 degrees Fahrenheit. It's hotter than the sun, which is, let me remind you, an actual star. And for some reason, it's still alive and lives as if nothing happened. Unfortunately, sooner or later, the planet will disappear anyway. It's slowly evaporating itself due to the incandescent atmosphere. But still, it somehow managed to survive the journey through the star, which isn't typical for regular planets, to put it mildly. I envy this willpower. However, not all planets are so lucky. Some are gradually being destroyed by their stars, and there is even an entire system among them. This last planet is a sad loner. It's located 870 light-years away from us. The journey by ship to it would take about 25 million years. This planet is about 1.5 times more massive than Jupiter. This is a very sad, dark planet. A doomed gas giant, which is very similar to hot Jupiter, orbits its star all alone. At the same time, it's located so close to its star that its orbital period takes just 1 day. Of course, because of this proximity, the star gradually absorbs WASP-12b. The scorching heat of the star is slowly destroying and devouring the planet's atmosphere. The planet has only around 10 million years left. But what's more interesting, because of this stretching, WASP-12b acquired the shape of an egg. It doesn't even resemble an actual planet anymore. It's also very hot. The surface temperature of the gas giant reaches 4,000 degrees Fahrenheit. Also, a spectrograph of cosmic origin, or COS for short, found that the planet exchanges matter with its star. They're located so close that they give each other part of their chemical elements. This is a common phenomenon in closely spaced binary star systems, but this is the first time scientists have seen this in a star-planet relationship. What a unique system. To be honest, if I was guaranteed complete security, I'd be excited to visit at least some of them. What about you? Please let me know in the comments.
Jupiter's moon Europa is covered in a thick layer of ice, but underneath it is a vast ocean of water, measuring up to 100 miles deep. Water ice was previously thought to be rare and only common on Earth. But it can, in fact, be found all over the solar system, even on Mercury and the Moon. Saturn is less dense than water, so if it were thrown into a giant pool, it would float. Space isn't supposed to be black. There are stars everywhere. Shouldn't they light up everything around? You don't see stars wherever you look because some of them haven't existed long enough for their light to reach Earth. There are 8 confirmed planets in the solar system, but evidence shows there can be a 9th. We just haven't discovered it yet. Organic matter could have been brought to Earth by comets, since it has been found on several of them. Saturn also has a never-ending storm, just like Jupiter, but it's also peculiar for its shape. It has 6 distinct sides. Mercury and Venus are the only planets in the solar system that have no known moons. Jupiter has 79 known moons orbiting it, the largest of which is Ganymede, and it's bigger than Mercury. It was thought that the Milky Way was a belt before, but now we know it's a spiral galaxy. Footprints on the moon can't disappear because there's no wind to blow them off the surface. There's a theoretical possibility of a white hole, the reverse of a black hole. Nothing can enter it from outside, but light and matter can escape from within it. Although there are trillions of stars in space, we can only see a tiny fraction of them in the sky. Charon, Pluto's moon, is half the size of its planet, which is why Pluto orbits a bit around a spot outside its own axis. All the objects in space, including planets, interstellar dust, and whole galaxies, comprise just about 4% of the universe. The rest is dark matter and dark energy that can't be seen and isn't fully understood. In the star system of 55 Cancri, there are 5 planets, 4 of which are gas giants, similar to Jupiter and Saturn. But the 5th one, or rather the first because it's closest to the star, is different in a most horrible way. 55 Cancri E is so close to its sun that half the planet's surface is a literal ocean of molten lava. The other half is in eternal darkness because it never sees the sun. The planet is always turned to its star with one side, and between the scorching and the dark, there's the twilight zone, a thin strip of gloomy nothingness. HD 189733b, I won't say that again, is the only exoplanet in the orbit of its star, and at first glance, it looks quite pretty. Blue and white swirls making up wondrous patterns on the surface. But these pleasant colors actually come from hard silicate particles in the planet's atmosphere, which means it rains glass here. Plus, the glass falling from the sky travels horizontally at hypersonic speeds, shredding everything in its path. Kepler 70 is a hot blue dwarf star that exploded into a red giant some 18 million years ago. At the time, it was orbited by at least 2 planets, the closer of which was a Jupiter-like gas giant. Its name was Kepler 70b, and it still exists. But the overgrown star consumed it and transformed it into a blazing hot rocky world. Right now, it's one of the hottest planets ever discovered. Its temperature is higher than the surface of our sun. It was lucky to survive spending time inside the star, but it's evaporating now, and will probably be no more in the near future. If the sun was the size of a front door, our planet would be the size of a nickel. In other words, the sun could fit more than 1 million Earths. Moon rocks have a super slow erosion rate. That's why the Apollo astronauts' footprints left on the moon are likely to stay there for 10 to 100 million years. Another one of Saturn's moons, Iapetus, has unique two-tone coloring. The difference between the satellite's 2 hemispheres is impressive. One of them is light and the other is eerily dark. Scientists haven't figured out this mystery just yet. All the planets of the solar system would fit between Earth and the Moon with some space left. Yes, there's lots of space in space. Saturn isn't the only planet that has rings. Gas giants Uranus, Neptune, and Jupiter have rings of their own, but they're thin and almost impossible to see. NASA can convert plasma waves, radio waves, and magnetic fields into audio tracks and listen to what's happening in space. They record all kinds of intriguing sounds, from beeps to ambulance-like howls. At the same time, space itself is an eerily silent place. There are some sound waves and vibrations, but people can't perceive them. On Earth, people are used to a beautiful sunset that's painted in hues of orange, red, and yellow. On Mars, however, the normally pinkish-red sky turns blue as the sun goes down under the horizon. It's because Mars is much further away from the sun than Earth, making the sunlight less intense. The fine dust in the Martian atmosphere absorbs the blue light and gets rid of the warmer colors that you typically see on Earth. Whether it's blue or yellow, both sunsets look spectacular. Humans have been exploring space for over 60 years, and the effort has certainly paid off. All the planets in our solar system have now been explored, even the dwarf planets of Pluto and Ceres. Most of the exploration was done by NASA's Voyager program, which began in 1977. Voyager 1 and 2 collected information on the planets, their moons, and their unique system of rings and magnetic fields. These twin spacecraft continue to send data back to Earth, and Voyager 1 is currently in interstellar space. On Earth, sound waves make air molecules vibrate, which is why we're able to hear sound. Other planets and moons allow sound to travel through mediums like their atmospheres and oceans too. In space, though, it's said that there is no sound, since there aren't any molecules to vibrate and deliver sound waves. However, not all researchers agree on this, given that space isn't just a desolate vacuum. In between the emptiness, there are clouds of gas and other stray particles, so, depending on where you are, sound waves can be possible. Discovered in 2017, Kelt 9b is the hottest planet we know of. That's because Kelt 9b orbits really close to its star, which is called Kelt 9. This thing is way hotter and bigger than our Sun. Experts believe that the giant star might someday evaporate the entire planet with its intense heat. Kind of a sizzling solar sauna, wouldn't you say? You wouldn't? Okay. One moon day is equal to about 29 days on Earth. It takes that long for the sun to cross the lunar sky. People always see the same side of the moon. The Earth's gravitational field makes the moon spin around its axis slower. That's why it takes the moon the same time to rotate around its axis as to orbit around the Earth. It was only in 1959 that people could finally see the other side of the moon, thanks to a photo taken by the Russian spacecraft Luna 3. The other side of the moon is more mountainous than the one we see from Earth. It can be explained by the Earth's gravity, which made the crust on the visible side of the moon thinner. Craters on the moon were left by asteroids 4.1 to 3.8 billion years ago. They're still visible, only because geological changes on the moon aren't as active as on Earth. The moon's gravity is only 1/6 of that of Earth's. You would be able to walk a distance 6 times longer and carry a weight 6 times heavier there. Though it's easier to walk, it's more dangerous too. An astronaut's foot in a heavy spacesuit might sink into the moon's ground. Long-distance jumps can be uncontrolled and dangerous, as the moon's surface is full of deep craters. Because of the low gravity, lunar dust consisting of tiny hard and very sharp particles and smelling of gunpowder is all over the moon. It makes a mess, causes symptoms like hay fever, and gets into spacesuits, ruining them. It's not all bad though, since at sunset and sunrise, the dust sort of dances. It floats above the moon's surface because electromagnetic forces make the particles float up. The moon does have a kind of atmosphere which is called an exosphere. It consists of helium, neon, and argon. It's 10 trillion times less dense than on Earth. Have you ever wondered what it would be like if every planet in our solar system was the size of Earth? Well, it's time to dive into this mind-boggling scenario. Let's imagine what each planet would look like if they were as big as our beloved blue planet. Would the barren red landscape of Mars suddenly become a lush green oasis? Would the massive swirling gas giant Jupiter just disappear? And how would it affect our solar system as a whole? Are we all doomed? Buckle up and let's find out. The first planet on our list is Mercury, the smallest planet in our solar system. But now, forget about the moon-like Mercury. Instead, picture yourself on the surface of a super dynamic incandescent inferno. There are a lot of craters and active volcanoes around you, and right in front of you is a huge, blinding bright sun. What a nightmare! But let's break these changes down. Well, along with the size of Mercury, both its mass and gravity would increase. In that case, it's possible that Mercury would have more atmosphere. Temperatures on Mercury are extreme, not only because it's very close to the sun, but also because of its very thin atmosphere. So during the day, the temperatures there reach 800 degrees Fahrenheit. And at night, it becomes terrifyingly cold, down to -290 degrees Fahrenheit. But now, when the gravity is stronger, Mercury could have a denser atmosphere, so the heat would be better distributed across the planet. And the atmosphere isn't the only thing that could make it hotter. If Mercury became bigger, it would likely experience increased internal heating due to gravitational compression. And hypothetically, its tectonic activity could increase. In other words, more interesting landscape, more mountains, and more scary active volcanoes. Congratulations, you've turned Mercury into Venus 2.0. For us, all these changes wouldn't be very pleasant. Now it would become much harder to send our spacecraft there, so it's better for Mercury to stay as it is, small, calm, and boring. Basically, the complete opposite of our next planet, Venus. So what would happen to Venus if it was Earth-sized? Actually, nothing. It wouldn't change at all because Venus is already almost the size of Earth. It's even called the Earth's twin, although twin is a big word, of course. In reality, we couldn't be more different. Venus is often called the morning star because it's so bright and visible in the sky. But don't let its beauty fool you. This planet is one of the most inhospitable places in our solar system. Its surface is hotter than a freshly baked pizza, around 900 degrees Fahrenheit, and it's covered in thick clouds of sulfuric acid that would dissolve any human who tried to visit. So, unfortunately, you won't be planning any trips there anytime soon. So let's move on to a planet that, unlike Venus, could potentially become a new home for us, Mars. Picture yourself standing on Mars's surface, watching the blue sunset and breathing in a refreshing breeze of air. Yes, you read that right, air. Moreover, you could be surrounded by plants, animals, and basically feel like you're on Earth. But how is that possible? Bigger Mars would have a stronger magnetic field and gravity. This would lead to a richer and denser atmosphere. It would likely have a wider range of gases, including oxygen. Wouldn't that be cool? Also, a denser atmosphere could distribute heat across the planet, so Mars would become much warmer and cozier. And here comes the most important change: liquid water. Mars actually has some frozen water at its poles and in subsurface reservoirs. But with a stronger gravitational pull, it could potentially stabilize liquid water on its surface. Hooray! However, it's not all fun and games. New Mars would also have a volcanic personality. It's already geologically active, but now its internal heat and pressure would skyrocket. That means more frequent and more crazy volcanic eruptions. Imagine how exciting it would be to witness such eruptions on another planet, if you manage to escape the consequences. In general, the planet could become greener and lusher, but not safer, although it would still be great to see it. But it's time to move on to the giants of our solar system. And if we're enlarging the planets before, now it's time to squeeze them really, really hard. If Jupiter became 11 times smaller, oh boy, what a disaster that would be. The first thing we'd notice is a change in gravity. And I say we'd notice because now we'd have no choice but to move somewhere. Jupiter experiences from 30 to 100 collisions with large asteroids per year. No big deal, all because of its strongest gravity, which attracts them all and protects us. But now our big protective brother has turned into a small baby. Say hi to a bunch of asteroids. Oh, and say bye-bye to Jupiter. This planet is known for its thick, swirling atmosphere. But with a weaker gravitational pull, Jupiter would probably have a hard time holding on to it. So over time, it would slowly escape into space, leaving behind a thin atmosphere composed mainly of nitrogen and oxygen. We'll also have to bid farewell to the iconic appearance of another giant, Saturn. The most noticeable difference would be the disappearance of its famous rings. Made up of small particles of ice and rock, the rings are a unique feature of Saturn. But with Earth's gravity, they would either fall onto the planet or scatter into space. Bummer. Saturn is also a gas giant, just like Jupiter. Its atmosphere is made up of mostly hydrogen and helium. But if it were Earth-sized, its gases would be compressed due to the increased gravity. This would make it much denser. That means Saturn's overall size and shape would change. Theoretically, if we squeeze Saturn hard, it could potentially become a brown dwarf. It's a type of failed star that lacks the mass to sustain nuclear fusion, but emits heat and light. So, Saturn could stop being a planet altogether. The weather on it would probably have changed too. All its crazy storms, such as the famous hexagonal storm at its North Pole, would have become weaker and calmer. The next giant is Uranus. Let's try to compress this poor fella. First off, the surface gravity on Uranus would be much weaker than it is now. Its atmosphere might also change. If Uranus was smaller, it could have a thinner atmosphere and different gases altogether. This planet is pretty chilly, with an average temperature of -353 degrees Fahrenheit. Ugh. But if it was the size of Earth, it might actually warm up a bit due to its reduced volume to surface area ratio. Don't get too excited though, it would still be way colder than the coldest spots on Earth. As you can see, gas giants don't easily go through all this shrinking, except perhaps one of them. Surprisingly, small Neptune would become much friendlier. For starters, it would probably be a rocky planet with a tiny atmosphere. That means no more gas giant, but instead, a planet that's easier for humans and critters alike to live and move around on. Speaking of movement, because of the smaller size, the gravity on this new Neptune would be almost the same as Earth's, making it a heck of a lot easier to walk and jump around. No more floating away into space. Now, the atmosphere of the original Neptune is so thick you could barely see your hand in front of your face. And the surface pressure is about 100 times that of Earth's atmosphere. But our new Neptune would be much different, with a much thinner and less dense atmosphere. It would still have some methane, water, and ammonia in it, but nowhere near as much as before. Finally, the temperature. The current Neptune is freezing, with an average temperature of about -370 degrees Fahrenheit. But if it was the same size as Earth, it would likely be much warmer, just like Uranus. Ah, that's more like it. What a planet that would be. That's it for the changes in the planets. But what would happen to the entire solar system if we made all the planets so small? It's hard to predict, but it's clear that their gravity and orbits could change a lot. It's unlikely that any of them would have flown into outer space, or crashed into each other, or something like that. But many of their orbits would probably become quite unstable, and the number of collisions with asteroids would have increased significantly. Of course, all this is purely speculation. It's not like we can actually test all this. But it's still a pretty interesting thought experiment, and it makes you appreciate just how unique and special our solar system really is.
Now, Mercury is the planet that's usually closest to Earth. Does that surprise you? Did me. Venus certainly gets closer to us than Mercury. It can be as close as 25 million miles. After all, Venus is the second planet from the Sun, and Earth is the third. Even Mars gets closer to Earth than Mercury. The red planet can come as close to our home as 35 million miles, as it will in the year 2287. I won't be around for that. The average distance from Earth to Mercury is 48 million miles, but Mercury is still usually the closest planet to Earth. That's because Venus is usually somewhere on the other side of the Sun for 112 days, and Mars is usually far away in its highly elliptical, almost 2-year-long orbit. That leaves Mercury zipping between the Earth and the Sun every 44 days, and thus usually closer to Earth than either Venus or Mars. Hey, good trivia question to pull on your friends, isn't it? 22 spacecraft have successfully flown to Venus, and over 30 spacecraft have flown to Mars, but only 2 have ever gone to Mercury. So, what's so hard about going there? Well, it has to do with the Sun. Mercury is not only the planet that is usually closest to Earth, it is also the planet that is always closest to the Sun, 28.6 million miles close, to be precise. Being that close to the Sun creates navigational challenges, to put it mildly. Any spacecraft going to Mercury gets accelerated by the tremendous gravitational pull of the Sun. The spacecraft will be moving too fast to go into orbit around Mercury. That's why the first spacecraft that went to Mercury, the USA's Mariner 10, merely flew by Mercury 3 times, but made no attempt to achieve orbit around Mercury. The only other ship to go to Mercury, the USA's Messenger spacecraft, took 6.5 years to get there. Now that's a trip! Messenger did achieve orbit for a period of 4 years before finally running out of fuel and crashing onto the surface of Mercury on April 20, 2015. Many other spacecraft have flown to Jupiter in about the same time or less than it took Messenger to go to Mercury. The hang-up is the deceleration of the spacecraft. Quite simply, it takes too much onboard fuel supply to fire the engines in the reverse direction and brake the speed of the ship against the Sun's great gravity. Slowing down sufficiently to get into orbit around Mercury is a no-go using rocket power. Some other way had to be found to slow Messenger down, a way that didn't use much or any fuel. Messenger was a hefty 2,400 pounds or so, loaded with 9 pieces of state-of-the-art scientific equipment. Now, 55% of the total weight, or about 1,300 pounds, was fuel. But this fuel would not be used to slow the spacecraft down. The fuel would be used for 5 engine burns associated with gravity assists and also for orbital adjustments once Messenger got to Mercury. Now, gravity assists uses the gravity of a planet and the planet's orbital velocity to either speed up or slow down a spacecraft. If the ship approaches a planet at a forward-moving angle, that is, an angle in the direction the planet is revolving around the Sun, then both the planet's gravity and the orbital velocity of the planet give the spacecraft a slingshot boost, greatly increasing the speed of the craft and sending it off in a different direction. This boost in speed can be added to by the spacecraft firing its rocket engines at just the right time. Both of America's Voyager probes used Jupiter's massive gravity to slingshot them to the outer gas giant planets and eventually out of the solar system. Gravity assist can also be used to slow down a spacecraft, as in the case of Messenger. By entering a planet's orbital path ahead of the planet's gravity pulls back on the spacecraft and slows it down. An engine burn is necessary at this time to escape the orbital path of the planet. Messenger performed 1 gravity assist flyby of Earth, 2 gravity assist flybys of Venus, and 3 gravity flybys of Mercury. Only then had Messenger been slowed enough to enter into orbit around Mercury. The probe traveled an astounding 5 billion miles to get to Mercury from Earth. That's farther than Pluto is away from Earth at its most distant. The name Messenger is an acronym, almost as clever as its intricate flight path to Mercury. Because Mercury is the fastest-moving planet, the ancient Greeks appointed Mercury as the messenger of Olympus. News traveled fast even back then. Messenger really stands for Mercury Surface, Space Environment, Geochemistry, and Ranging. What do you think? Did they have a contest to come up with that? Now, the good news is, there's another mission to Mercury underway right now. It is a combined ESA-JAXA space mission that is bringing 2 orbiting satellites to Mercury. The mission doesn't use an acronym for its spacecraft, it has a real name, Bepi Colombo. No, it's not a cartoon character. Dr. Giuseppe Colombo, after whom the spacecraft is named, was an Italian mathematician and professor of applied mechanics. He worked with NASA on the Mariner 10 mission to Mercury. Bepi is Giuseppe's childhood nickname, which everyone knew and loved him by. NASA had been content with 1 flyby of Mercury, the first ever, but Professor Bepi calculated that with a slight adjustment of the flight path to enable a gravity assist at Venus, Mariner 10 could fly by Mercury again and again on different orbits around the Sun. Thanks to Bepi, NASA got 3 flybys of Mercury for the price of 1. Bepi Colombo, the spacecraft, is scheduled to perform 9 gravity assist flybys, 1 at Earth, 2 at Venus, and 6 at Mercury itself. Each planetary deceleration slows Bepi Colombo relative to the speed Mercury is moving around the Sun. This will allow for orbital insertion. Otherwise, Bepi Colombo would head off into the Sun. Now, once in orbit around Mercury, Bepi Colombo's Mercury Transfer Module, or MTM for short, will release 2 satellites, 1 European, the MPO, Mercury Planetary Orbiter, and 1 Japanese, the MEO, Mercury Magnetospheric Orbiter. Both are expected to orbit Mercury for 1 year. Altogether, the MCS, Mercury Composite Spacecraft, consists of the MPO, the MEO, the MTM, and MOSIF, which protects the spacecraft from the Sun and houses the electronics for MEO. This alphabet soup of mission components highlights the other reason it is difficult to get to Mercury. After 6 gravity assist slowdowns, 6 engine burns, 18 orbits around the Sun, 6.5 years of travel time, and 9 billion miles of distance, you have to bring a tailored complex of equipment. It's like that mountain picnic you'd like to go on. You can't just drive there. You have to hike a long way up a tricky mountain trail and bring along insect repellent, sunscreen, and your hat. Oh, and lunch and beverages. It's not easy. Bippo Colombo has packed it all, including lunch. Nah, not really. The design is incredibly complex. Nothing can face the Sun, not even the solar panels. The solar panels must be kept turned almost to a right angle to the Sun, or the heat and particle flux will corrode the solar cells, and without electricity, you have nothing. Therefore, at right angles to the Sun, the solar panels must be extra long, as if there were only a little bit of sunshine. Bepi's solar panels are 50 feet long. The sun shield must remain gyroscopically aligned towards the Sun so that all instruments are always in the shade but still have a line of sight to what each is meant to monitor. And there are a lot of instruments, 5 in the JAXA orbiter and 11 in the ESA orbiter. It's one amazing picnic. Anyway, the science objectives are meant to add to what we have learned from the previous 2 missions to Mercury. The data collected by Bepi Colombo will enable scientists to study the planet's interior and composition, along with Mercury's geology and surface morphology, Mercury's magnetic fields formation and evolutionary history, the planet's solar-wind interactions, and overall environment. As a metal-rich planet, Mercury may hold a vast wealth of minerals that MESSENGER failed to detect. Bepi Colombo launched in October 2018 and still has a long way to go before it goes into orbit around Mercury. However, Bepi has already flown past Mercury and returned new photographs. The European Space Agency is excited about its first hot mission. All of the ESA's previous missions have been cold missions to objects further out into space, such as Mars, the asteroid belt, Comet Rendezvous, and elsewhere far out in the solar system. Well, all I can say is, best wishes to Bepi Colombo. Let's hope all goes well on its 800 degrees Fahrenheit mission to Mercury. Let's hope that Mercury's long tail of exosphere gases, sodium, magnesium, and potassium, blown off the planet's surface by the solar wind, don't fog up the lenses or coat the solar panels. Have a nice time! Ciao, baby! As scientists continue to explore the vast expanse of the universe, they've made some incredible discoveries that have left them with more questions than answers. From a scorching super-Earth to a football-shaped world, the exoplanet discoveries of 2022 are truly out of this world. So, hold on tight. The future of exoplanet discoveries is looking brighter than ever. Number 1. New type of exoplanets. Red dwarfs make up over 70% of all stars in space. So, in September of 2022, scientists decided to take a closer look at the small worlds orbiting them. What they found was amazing. New type of exoplanets that were made of half rock and half water, either in liquid or ice form. The researchers suggested that these planets likely arose from icy material and were born far away from their stars, past the ice line, where surface temperatures are freezing. But they later migrated closer in, to where the astronomers detected them. This discovery could have huge implications in the search for life in the cosmos. Though these planets are loaded with water, they might not be covered in oceans. Who knows? Maybe one of them will be the next Earth 2.0. Number 2. Jupiter-sized world. Imagine a planet so massive and mysterious, it's like a hidden Jupiter in our galaxy. Well, we just discovered one of those orbiting a star just 379 light-years away. Just. We've named it the TOI 2180b, and it's got everyone talking. Why? Well, for starters, this planet takes a whopping 261 days to orbit its star, which is much longer than most distant gas giants we've come across so far. But that's not all. The temperature on this world is surprisingly mild, averaging at a balmy 170 degrees Fahrenheit. For comparison, the temperature on Jupiter and Saturn is around minus 280 degrees. It's like a bridge between the giant exoplanets we've found and our Jupiter. But the question remains, how did this planet get to be so different? Scientists are still trying to figure that out. Let's hope that we get some answers soon. Number 3. The Hulk Planet. This world is a place where the surface is covered in molten magma, and the year lasts just half a day. Welcome to TOI 1075b, an exoplanet that's been dubbed the planet Hulk by scientists. Located 200 light-years away, this super-Earth is one of the most massive ever discovered. Its proximity to its parent star causes its surface to reach scorching temperatures of 1922 degrees. It's so hot that any form of water would evaporate instantly, and the air would be filled with vaporized rock. But it's not just the heat that's impressive, it's also its size. TOI 1075b is nearly 10 times the mass of Earth, making it one of the most massive super-Earths ever discovered. But the mystery doesn't stop there. The planet's orbit takes just 14.5 hours, making it one of the shortest orbital periods ever recorded for a planet of its size. What an exciting addition to our catalog! Number 4. 3 doomed planets. Astronomers made a shocking discovery of 3 planets that are circling in a dangerous dance next to the slowly fading stars. Just a decade ago, scientists never even imagined such planets could exist. These gas giant planets, similar in size to Jupiter, orbit way too close to their slowly fading stars. They're basically walking on the edge. Take one of them, for example, dubbed TOI 2337b. Its orbit will likely send it hurtling straight into the fiery arms of its host star in less than 1 million years. Well, I won't be around then. As these stars enter their final days, they're pulling in nearby planets like a black hole, altering their orbits and potentially causing catastrophic collisions. And as these planets get closer to their stars, their atmospheres heat up and swell, leading to some mind-boggling differences in density. But despite the doom and gloom, studying these worlds could give us valuable insights into the evolution of our own solar system. Number 5. Planet with a barium's atmosphere. These are 2 hot blazing planets, each with an atmosphere made of the heaviest element ever found in an exoplanet, barium. These planets, known as WASP-76b and WASP-121b, are ultra-hot gas giants called super-Jupiters that orbit incredibly close to their stars. These planets are basically like giant balls of fire, with one side facing the star, cooking at temperatures hot enough to vaporize iron and other metals. But as the hot iron vapor is blown into the planet's cooler night side, it turns into liquid and falls as iron rain. And these planets held a special surprise for us. Barium is a heavy metal, about 2.5 times as heavy as iron. And yet, scientists were able to detect it in the upper layers of these planets' atmospheres. This is truly a mystery, and a puzzle we're still trying to solve. Imagine landing on a planet like this and looking at this rain of iron and the heavy barium in its skies. That would be awesomely horrifying. Number 6. The Football Planet. Get ready to have your mind blown, space enthusiasts, because we've just discovered the ultimate football-shaped planet, and it's unlike anything we've ever seen before. Meet WASP-103b, the ultra-hot exoplanet that's more than 1,000 light-years away from Earth. This gas giant is so close to its parent star that its shape is being stretched by the intense gravitational forces. But this isn't just a fun shapeshifter. It's also a valuable scientific discovery. By studying the planet's passes across its star, we were able to measure its deformation for the first time ever. It's like taking a snapshot of a planet in motion, and it's giving us insights into the extreme conditions that these planets can endure. This is truly a great discovery. Number 7. A zodiacal light. Are you ready for a cosmic ghost story? Scientists and high school students in China have uncovered a spooky phenomenon on 3 distant exoplanets. It's called zodiacal light, a glow that's similar to the one seen here on Earth during sunset. But this isn't just some eerie light show. It could hold clues about the makeup of these potentially habitable worlds. Imagine watching the sunset from a dark spot on Earth, and instead of darkness, a triangle of light appears. That's zodiacal light. It's caused by sunlight reflecting off dust particles that fill the solar system, the remains of asteroids and comets. A team of researchers analyzed 47 potential habitable exoplanets named Kepler 69c, Kepler 1229b, and Kepler 395c, all super-Earths, had signs of this light. This discovery is more than just a spooky phenomenon. It could reveal information about the presence of asteroids and comets in these exoplanet systems, which could be difficult to detect otherwise. So that's pretty neat. Number 8. A planet with silicate clouds. Introducing VHS 1259b. Not a home video recording system, but a strange and exotic world shrouded in mystery and wonder. A place where the clouds are made of sand and the sky is forever red. This isn't the stuff of science fiction, but a real-life discovery made by the brilliant minds at NASA. This is a brown dwarf exoplanet that's making waves in the astronomical community. It's way too massive for a planet, nearly 20 times the size of Jupiter, but it's not quite a star. It's something in between, a cosmic enigma that defies definition. But what's really crazy about VHS 1256b is its atmosphere. Scientists have discovered that this strange world is cloaked in thick clouds of silicate grains, similar to sand. It's the first time this kind of cloud has ever been detected on an exoplanet, and it's a discovery that's sure to change the way we think about the universe and the possibilities of life beyond our world. And there you have it, folks. The year 2022 was filled with incredible discoveries and groundbreaking findings in the world of exoplanets. But this is just the beginning, as scientists and researchers continue to explore the vast expanse of space. We can only imagine what other wonders await us. So, let's keep looking. Who knows what secrets the stars hold for us next?
.5 feet with the Earth's gravity. Verification complete. Now the simulation room will recreate Mercury.
It's so hot in here.
Yes, it's like standing next to a volcano. Your jump is 4 feet high. Now switch to Venus.
Wow, this place looks scary.
On the real Venus, everything is toxic.
I feel no difference.
Yes, the gravity here is almost the same as on Earth. Switch to the Moon. Gravity on the Moon is 10 times lighter than Earth's, 9 feet. The next one is Mars.
Huh? It's pretty comfortable here.
The gravity here is the same as on Mercury. 4 feet. Now, prepare for the struggle.
Huh? What do you...
There is no solid surface on Jupiter. Although Jupiter is a great deal larger in size, its surface gravity is just 2.4 times that of the surface gravity of Earth.
It's hard to even stand here.
Only half a foot. Got it. Switch to Saturn. There is no solid surface here either, but Saturn's gravity is almost the same as Earth's. Now Uranus.
It's so cold.
It's 5 times warmer here than on the real Uranus.
Seriously? My legs are...
1.7 feet. Gravity is slightly weaker than Earth's. That's Neptune for you. Your jumps are 1.3 feet high. Gravity is slightly stronger than Earth's.
Get me out of here!
Turn off the simulation.
Imagine, all the planets from the solar system had a meeting and decided that Earth should move to another galaxy. Then what? Well, my friends, if Earth got kicked out of the solar system, let's just say we'd be in for a bumpy ride. As you may know, each planet occupies its own orbit in relation to the Sun, guaranteeing the perfect functioning of our solar system. But it wasn't always like this, though. Billions of years ago, planets and asteroids kept constantly bumping into each other. It took some time before each planet found its own personal orbit, and our system took the formation it has today. Now, as you may know, the most important organizing factor of the solar system is gravity. Gravity attracts every piece of matter to every other piece of matter in the universe, and the bigger the mass, the bigger the gravity. The Sun makes up 99.75% of all the mass in the solar system. It's precisely the Sun's gravitational pull that has kept Earth on a steady and reliable path. But it wouldn't take a surreal interplanetary meeting for Earth to go rogue. This is an actual possibility, an unlikely but real one. For instance, if any rogue planet or star were to travel close to the solar system, its gravitational force could mess up our planetary organization. And did you know that this has actually happened before? Some 70,000 years ago, a red dwarf passed through the Oort cloud and messed things up. The Oort cloud is an outer circle of space debris located on the edge of our solar system. It lies far beyond Pluto and the Kuiper belt and surrounds the Sun in a giant spherical shell. Apart from the 8 planets and the Kuiper belt, there is another asteroid belt between Mars and Jupiter. Now, scientists expect another red dwarf to pass by our solar system. It's an orange star from the constellation of Serpens Cauda. Astronomers expect it to pass near the Sun in about 1.29 million years, at a distance of about 99 billion miles. This star has about 60% of the mass of the Sun, which would be enough to cause a great disturbance in our system. Once the star entered our system, we'd be able to see it in the night sky without any equipment. It would be like watching a small orangish dot appearing in the sky. Over the months, it would grow bigger and bigger until we'd see it during the daytime. At a certain point, it would become so big and bright that we wouldn't be able to look at it directly. Just like people say we shouldn't do with the Sun, but we look at it directly anyways, right? At this moment, the night sky would fill with an eerie red glow, and after a few months, the orange star would start shrinking again, turning smaller than the Sun. But then, wait, the Sun is turning smaller too. Well, yes. The passing of Gliese 170 took Earth out of its orbit, and its gravitational force pulled us out of our natural alignment. Now the Earth will roam through the solar system until it reaches outer space. So, what would happen with our planet if this were to really happen? First, the Earth would leave what is known as the Goldilocks zone, also known as the habitable zone. It's a rather narrow part of the solar system where human life can thrive. What's its success secret? Water in a liquid state. Astronomers have discovered that Mercury also has water, but only in its northern and southern poles, where light never reaches. Pluto, the dwarf planet at the rear end of the solar system, is 30% water, but much of it is hiding under a thick layer of ice. If the Earth ever did leave its privileged place orbiting the Sun, it would travel around the galaxy at its orbital speed of 67,000 miles per hour. That's 1,000 times faster than a cheetah can run. Pretty fast, huh? So, in about more or less a month, humanity would see the red giant Mars on the horizon. By then, we would be getting around 44% of the sunlight we once had. If someone wanted to begin a new civilization, this would be the perfect moment. With reduced sunlight, it would be more difficult for plants to continue doing photosynthesis, so most of the flora on our planet would begin to perish. A few days after leaving Mars's orbit, our planetary spaceship would face its first challenge. traveling through the asteroid belt. It's a collection of small, rocky, metallic bodies. They're basically leftovers from the Big Bang that created our solar system 4.6 billion years ago. So, in a way, it's almost like we were traveling in time, right? Luckily for us, the distance between one asteroid and the next is about 600,000 miles. So, after passing one asteroid, it might take us a while before running into the next. If we make it through this journey intact, then we'll see the first gas giant in our galaxy, Jupiter. Up until this moment, our loyal moon has been following us as we travel inside the solar system. But, Jupiter's huge mass might steal our moon away from us. After all, Jupiter's gravity is twice as strong as Earth's. If our moon did join Jupiter's orbit, it would be no less than its 80th moon. A bit too many moons, if you ask me. At this point in our travels, the Earth's atmospheric temperature would have fallen drastically to around -229 degrees Fahrenheit. So life on Earth would only be possible in very specific places. Most of our planet's water would be frozen at this point, but only on the surface. Thanks to the Earth's core activity, it would heat our oceans from below, allowing heat to escape and maintain some water in the liquid state. In fact, the Earth's core would remain active for billions of years after it has left orbit. In this scenario, microbes living near hydrothermal vents would thrive. But perhaps some life would also be possible near the heat provided by thermal vents above the surface, in places like Yellowstone Park. A great option for humanity would be to build cities deep underground. This would be our best bet if we wanted to keep human life on planet Earth. 10 years after our departure, we would be deep into the interstellar voyage. We'd be over 2.8 billion miles from the Sun. Our solar system would be nothing but a distant memory. If you were still living on Earth at that point, then you'd probably be coexisting with great technological advancements. Humans could build entire underground cities using geothermal energy. Maybe we'd even discover how to turn ice into power and create a sustainable and abundant system for fuel. Ice would also be our main source of water, and by then, the transformation process wouldn't be as expensive. Underground crops would thrive, but some plants would be better than others. Moss, fungi, and algae would be some great alternatives, as they are much easier to farm and grow in large numbers. This would mean that most of our diet would be plant-based, as it might be hard to keep grazing animals under the ground. Humanity could go on living thousands of years this way. If Earth happened to pass by some star with a habitable planet, we might even attempt to make a home on another planet. Spaceflight would become easier without the atmosphere in the way. So, the idea of venturing into other planets would no longer seem too surreal in this scenario. The only thing that we would rather not happen to us is Earth running into a black hole. If that happened, let's just say we'd all be turned into spaghetti. Not literally, but we would go through a process that is called spaghettification. In this case, planet Earth, and everyone still living on it, would be vertically stretched up to the point of, vanishing. But that's the subject of another video. Fortunately, even if all this could be true, we wouldn't be caught by surprise. Thanks to scientific and technological advancements, we would be able to predict if a star were to pass too close to our home planet. And even if we couldn't stop a star, we would most certainly manage to do everything to prepare. So, who knows? Maybe the future generations will be watching